informação post. This is the Degen.
Hey, can you guys see me? Okay, all right, great. Great, okay, fantastic. All right, hey, you know what? Let me try. Maybe the lighting will be better if maybe this is light mode. This is the night mode. Yeah, the funny thing is, it's not the lighting in the room. Hey, by the way, you should all feel free to switch on your cameras, okay? Yeah, switch on your cameras. The lighting you see is not really the lighting, ambient lighting. All of the lighting you see is essentially from the screen. So if I go all, like that, I don't know. Anyway, so I'm going to switch this off night mode so I can get a better view, right? Right now it is also, I can see that clearly. Wait a sec. Switch off night mode and just give me 1 sec, okay? Just since we started sooner, just give me 1 sec to figure this out. All right, it's not going to work. All right, let me just increase the brightness here as much as possible. Okay, full screen. And I'll switch glasses along the way. All right, so that's great. I'm glad to see you all. Okay, I'm glad to see you all. And great first class. And hopefully all of you, more people will join because I think attendance is mandatory. Okay, and for today, what we'll do is just make a comment saying yeah, yes, whatever, hi, or whatever in the participation, or in whatever that thing is. What is this? Comments, chat. Okay, chat. I won't look at the chat during the meeting, and it's hard to. So don't put any questions there. Discussion points. If you have any discussion points, you just raise your hand and just interrupt. Butt in whoever is talking. It doesn't matter. Just wait for a little gap and just shoot your question. That way, it's a whole lot better. I keep telling that to the previous previous batches too, but many of them forget. But you have to remember, no matter who is talking, we just assume that it's okay for all of us to just butt in at any time. Yeah, I think that will make it easier for us. Because I don't think lots of people have multiple monitors where they have the chat window on one screen and then all the faces on the other, right? And if I had a choice between just chat and faces, I'll just go for the faces, yeah, and the cameras rather than chat. Okay, great. So all of you, right? Just feel free to switch on your cameras whenever you're ready. And here's my plan for today. I'm actually just very happy to see you all. Okay, and I'm happy to see that there is a great deal of activity in the questing too, and a lot of people are making progress. And even better, a lot of people are actually helping other people out, right? So I'm very happy to see that. Always. Okay, so anyway, so my plan for today's lecture essentially is we're going to cut through all introductions and getting to know each other. All of that will just happen over time. In the next few lectures, we'll all know each other, and we'll be helping each other and knowing each other by their Reddit handles. So the superficial stuff, we can actually save the time on getting to know each other by name. But I can actually tell. In a couple of lectures, I'll actually know most of your names, provided I switch my glasses. Okay, right now I can just make out most of the names, but I can't actually read them. It's just strange. It's still a 15-inch monitor, but brightness. That is the max brightness. Okay, all right. Okay, so and so today what we'll do essentially is, if you have any questions at all about this class, about the course, how things are going to run, happy to take them. Yeah, I'll take them any time too. Any class you can just say, hey, I have an administrative question or something about the class or something about the way you introduced that concept was confusing to me. Maybe you can try a different way today, because our class is all about experimentation, and we're going to try a lot of things that we experimented with last quarter. Okay, unfortunately, towards the end of last quarter, and I had no idea it was going to, resonate so strongly with the students, right? And it was basically, it's not like speed coding. Okay, it looks like speed coding, and practice for leak code and shit like that. No, totally not. So what it is essentially we pick a task, we come up with some maybe a lame ass project, but it's something interesting and something that'll work. Make a chain of 15 linked lists, linked nodes in a list, or something like that. Okay, and we say that should be done in 3 minutes time. Okay, and the first time you do it, it's not going to be 3 minutes. It's more like 30 minutes. Okay, because you're going to run into pointer errors and all kinds of things. I'm just talking about the end of the class. You'll be doing all this in like 6 weeks from now. You'll be doing stuff like this. Okay, but but we'll follow the same format all the way through. That's what I'm saying. And yeah, and so when people do that, we say 3 minutes, and one person does that in 3 minutes, and then another person on the screen takes over, and they start from a blank slate. Okay, blank slate, and do the exact same thing, not something different. Okay, exact same thing. 3 minutes. Maybe it's slightly longer this time, shorter. And by the time we got to about 7 or 8 people down the track, down the chain, people were just hopping on screen and getting it done in no time at all. They're just reading it off. And I think there is a lot to be said for memory-based learning. Okay, so in this day and age, when everybody's talking about understanding and emerging consciousness and meaning and things like that, it's all got its place. But I think, right, the fundamental precursor to deep learning, which is really understanding the concept, is memory-based learning. And I think a lot of kids, right, especially when my kids were going to school here and all, I think the culture really de-emphasizes or puts it memory-based learning on a smaller pedestal, meaning you don't have to memorize things as much as understand things, right? Because it also de-emphasizes the role of practice and things like that. But practice and going over things again and again, if you're doing math, for example, you have 50 or 100 problems at the end of each chapter, like 5 pages of text and there's 100 problems after that. I don't know, that's how my kids' math book and all looked a long time ago. But the idea is there is not to say, well, work through enough of these so that you understand, right? That's not the idea, right? So you work through some of those, you'll understand it, of course. But I think one of the key takeaways there is also just to do, even though you know how to do it, keep doing it again and again. So it just becomes like rote memory. And the importance of rote memory is not to be able to reproduce it later on at a drop of hat. Someone says, hey, do this, okay? And you say, well, I know how to do it, bam, 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 like that. Yeah, no, that is, people think, that might be the value of rote memory. No, actually, I think that is not, right? I think what happens is that when you memorize something, it is equal or equivalent in many ways to data stored on a disk versus data stored in memory, in RAM. Okay, if something is in RAM, you can process it at incredible speeds. We're using efficient algorithms that you'd be very, very unlikely to think of as something that works on data stored on a disk. Yes. Yeah. So I think having everything in a place where even if you're sleeping, your mind can just basically just churn through the data, right? Maybe in a dream or whatever it is, right? And get through it. That means you've got the practice, you've got the memory, you've tucked it all away in your head. You don't need a book. You don't need anything to tell you. You don't need someone else to tell you, you're right. That is right. You're not beholden to someone's authority, validation, or anyone, because you know what the hell it is. And that comes with practice, and the practice seals it in your memory. And the memory, I think the hypothesis is a wild hypothesis, right? So here, some of you majoring in psychology, come up with an empirical way to test this. Right, I'm pretty sure you can do these things, using MRA techniques and questionnaires and all kinds of clever ways to do these things. You can tease these things out from subjects, yes. But I think this is probably what happens. Right, when you memorize something, you have a much better chance of understanding it, right? And I think that people who say, I just want to understand things, yeah, you can get 2A, 2B, 2C, all the certificates in the world, right? I understood these things, I have these degrees, right? But you never really understood these things in a real productive way in which that you can, you don't distill things out of it, right? You just memorize many different ways of doing things. right? Or, not memorize. Anyway, so I don't know how we got started talking about that, digression. But I think what we'll do today and the rest of the classes too, I think I'd like to try this new technique. Okay, if it actually works, I'm actually like super excited. I'll take hey, all of the other guys also, right? Switch on your cameras. All the latecomers also switch on your cameras too, right? So I will actually suggest this technique to all the other faculty too, before I retire. I think it'll be really cool because then it'll actually bring the focus of science back to the arena of practice, okay? If you go to art, music, all of these other, you go to Foothill and go to art or music or something like that, they'll say you have to practice, right? Even though you know this thing, you got to keep practicing again until you get it right, right? Even in your sleep. I think that should also be the norm in science, right? Understanding just doesn't cut it. But understanding you can pass off at different levels. But practice actually gets into all the details and nooks and crannies. And I think if you look at all the great physicists, all the great scientists, they're all practitioners and great practitioners. What that means is that it's not that they understand things. They've had a lot of practice in the lab. They've done this experiment like a million times, right? Millions and millions of times, uncountable times. They've done it all kinds of silly ways, even paper is different, position on a table, even that would be taken into, account in some, they've done these things so many times, they get an intuition for the thing behind it, and it is just practice. It's the same thing when it comes to computer science, any science really, right? If you're, in chemistry or physics, you got to go in the lab, and you can't say, I read through the book, I understand all these things, the theory, it works. Yeah, okay, everybody understands everything at some level. But you got to go into the lab and do these things, and just like in math, okay. So it's just not just enough to know. Oh yeah, I know it's there's a second derivative. Okay, yeah, all right, that tells me something about the slope or how it increases, decreases, and shit like that. Yeah, okay. But if you work through like 100 problems involving that, why it is that gradient, or why is the gradient of the gradient. That is what the second derivative is, right? So some of you are probably doing that, the I don't know, it's called 4D, right? Math 4D, vector calculus. All of that is really useful, okay? So yeah, and being the first lecture, I'm pretty sure a lot of people are interested in AI and machine learning and stuff like that, okay? This is the right place, okay? Because you have to know the basics, okay? If you want to learn about gradient descent, or machine learning, or even large language models, even though it may not be statistical anymore, right? Because in the olden days, when you built a language model, I'll show you when you do my 2C and we do a extra credit project, I can show you through an extra credit a project. A language model at the base, at the core, is actually statistical. It gives you a sequence of words, and you get the probability of the next word being cat, right? Given the word before it was, the rat ran away from, right? Right? What's the next word? And then you have, and you can build a language model, and you can do that very simple, okay? Even with, after you're done with quest number, well, I don't know. It's actually doable in CS2A, that, the level of prediction, but it's the accuracy of the prediction grows with the language model. So I don't know how we got started talking about the language model and things like that. But basically, it is just a question of prediction, right? Anyway, so I shouldn't waste your time. Today's class, if you have any questions, generally I can answer, and it'll be an exception because I think we will code from the next class onwards, okay? Every class from the next class, we will actually code. And you'll notice that, in the forum, sometimes there's a question about VS Code, and I actually don't answer, well, I don't answer most of these questions anyway. But some of these questions about VS Code, I have no idea what the answer is because I don't know VS Code myself. Yeah, but we have a lot of people in the STEM Center. If you go to the STEM Center, almost everyone in the STEM Center knows I think it's VS Code and things like that inside out. Even Xcode, right? Even though it's a Mac environment, most of the machines in the STEM Center, they're Macs, yeah, and they have Xcode on them. If you're on a Mac, you should just use Xcode, okay? You don't have to bother about VS Code, installing VS Code, because VS Code has the plugin and things like that. I don't know. It's your personal choice. So yeah. So today's class, we won't do any code, okay? From next class, we'll just go into online GDB, right? So just something like that, and we can code in there. Most of the code, in fact, last quarter, we never used anything other than online GDB. That is really cool, isn't it? We completed CS2A, without having to use an IDE for any of the class exercises. Well, it's not like our class exercises were, lame. We actually did some cool stuff in our class exercises. If you go into our, well, I don't know, so I don't think I published the later class lectures, but I think some of the other ones before I came to know of the FERPA thing and all, they're actually live. You can go and look. And some of the projects we did in class, they're non-trivial. It's fun projects, and we never used an IDE for any of that. In fact, it's a long time since I actually used an IDE. Most of my code I just used an editor like Notepad or something like that. And that's what we did in our class, and that's what we're going to be doing from next class onwards. Today's class, what we'll do is that we're going to take turns again, and we'll just do problems in data representation. What time is it now? Yeah, 6:15. We got a lot of time. It's only been 15 minutes. Okay. Actually, let me also switch my glasses so that I can actually see what the hell. I think I can see better anyway. Let me put it that way. Oh, geez. Okay. So I've not worn this for such a long time. That's all dusty and all. Okay. Okay. I think that should do for now. Well, anyway, this is much better. Well, at least I can see all your faces now, okay? I couldn't see your faces before. Yes, that's great. Okay, fantastic. Okay. Hey, Andrew and Rachel and Chloe, Mitchell, right? Yeah. All of you switch on your cameras. Today, what we'll do is that, it's not going to be long, okay? I think, and by the way, because, your cameras are on today and your faces are on screen, I won't be putting this online, okay? What we'll do is it'll just be a private share on Canvas in Zoom, and we'll do that. But from next class, what we'll do is that when we code, what we can do is we'll have the cameras off, right? We'll only have our cameras on for occasional meetings like this when we're talking about general stuff. Most of the other times, what we'll do is someone's going to take over coding and they're going to code and share the screen. And I think when we do that, then I can then that lecture can also be put on YouTube, right? Because we're not sharing people's faces and names. Yeah, this is kind of strange because it should be possible, or at least YouTube, right? If if I was, the technology for this is so simple that they can actually detect faces and blur them out on in Zoom videos. Yeah, and it'll be a great feature. Zoom could offer that. Zoom could offer that in recordings, faces blurred, or private details blurred, right? Or accidental social security number accidental, right? Exposure blurred. All of that can be done, at a drop of a hat in technology these days. It'll be a cool feature for Zoom to add, right? Or YouTube to add. And then that would mean that our videos could just go live. And our universities or all these colleges that take pains to curate their videos to make sure sensitive info is not leaked, they could have a bit less effort. Never mind. All right. Okay. All right. So anyway, so today, if you have any questions, we'll do that. Otherwise, what we'll do is if you have any doubts about data representation, right, we can tackle that today. But otherwise, what I'm thinking is we'll just start off.
I'm just gonna blur my background
with maybe Ryan. Okay, Ryan. We'll start off. Do you have a canvas with a can you write on screen or something like that?
I just chill at home. I went to Countdown. Yeah.
Okay. Hey, Faith. I think we can hear you. Faith. All right. Okay.
Yeah, I gotta order.
Yeah, it's not displayed anyway.
Bro, is it on?
Okay. All right. So hey, Ryan, can you hear me?
Show me.
Yeah, I can hear you.
All right. So what you can do is you can actually share the entire screen. Well, let me make sure that I can. There's this thing here that says share screen. Yeah, all right. So I thought there was a system-wide setting in Zoom that says by default everybody should be able to share. I'll look for that, okay? You should be able to share your screen. After you share your screen, just go into Notepad or something where you can write, and then we'll start with a simple hexadecimal binary project, okay? And then after a few minutes, we'll just go to the next person, Chris, all right? So you're going to do exactly what Ryan did. Right, and maybe we'll just add a little bit, this time. This is experimental at this stage and this time, right? Because we need to find out the right problem that will occupy someone for 5 minutes, and then get that to replicate everybody. I think that would be a fun thing to do. All right, Ryan. So how about you take the screen, and Chris, you're going to be doing the same thing next, okay? So essentially, you can also get ready for that. So what we want is to be able to share your screen, and then you'll take over the whole screen, Ryan. After that.
Yeah, can you guys see it?
Yeah, and in fact, you know what? Yeah, okay. Well, today's video I'm not going to share, so you can have your cameras on. But I was thinking, from next class onwards, when people are coding and you guys are still here in that film strip, actually, maybe there's a Zoom setting that says, I don't have to record everything. Yeah, well, it's still Ryan. I can still see Ryan. All right, okay. All right, so, all right, Ryan can turn off his camera, or anyone who's sharing not today, tomorrow maybe, not tomorrow, Thursday, when someone is coding, their photo will be shown here, on the right. So, we won't be able to share the video after that. Okay, so you can switch off your camera. Wait, why I can't see myself? How come? Side-by-side gallery is not what I want. All right, what is standard? Oh, never mind. Okay. All right. Hey, Rena and Seth, you can actually switch off your cameras. Not today, right? Today's fine. But later on when we're going to record, anybody who's on screen, before you share screens, everybody should switch off the cameras. Okay. I think that'll be much better. Not today. Hey, Seth, okay, Rena. Hey, Rena, Rena, is that your name? Are you Rena on the forums? Oh, you are. Okay. All right. Okay. I thought it was, but I wasn't sure. Okay. And Faith and Mitchell, you guys should switch on your cameras too. All right. Okay. This is a browser. Is this a browser, Ryan?
Oh no, this is just a text file. Do you
Oh, it's a
want me
text
to?
file.
Yeah.
Okay. All right. So I'm thinking what we can do now. So I'm going to reel off a couple of conversion problems, and anybody who wants to say, all right, let's do that, we'll do that. Okay. If not, what we're going to do is I'll assume that it's too simple. We'll go on to the next most complex set of problems and so on and so forth. Okay. We'll start with simple. What was the first thing we did? Binary to decimal conversion. Yeah. Binary to decimal conversion. Actually, yeah, I think that's the easiest thing to do, right? Binary to decimal conversion. Suppose I give you a number, right? So how about someone, maybe Faith, all right, since you're on screen, all right? You haven't got your camera on, by the way, Faith. All right, since you're on screen, Mitchell, hey, Mitchell, wow, okay, on your screen, on your wall in front of you, behind you, I thought there was a person behind you. This looks like yeah. All right. Okay, great. All right. So the camera is off, right? So I couldn't see you. Mitchell, can you hear me?
Yeah, wait, sorry, what was that?
So, all right. So either you or Faith should just reel off of, I don't know, seven digit binary number. Okay. Binary is, you're just going to use digits 0 and 1 only. Like in decimal, you have 10 digits. In binary, you only have 2 digits. Yeah. You can actually just reel off a number in unary too. How would you reel off a number in unary? Can someone tell me how you reel off a number in unary? What is unary?
Base one.
It's
Would
one
that be
digit.
Talmud?
You can only have one symbol. You can only have one symbol.
Like, would that be
Oh,
Talmud?
hey, Sanatan.
Yeah,
Sanatan, you
yeah,
were saying something and I had to cut you off.
yeah. So basically, it would be a bunch of zeros.
Yes, it'll be a bunch of zeros. Thank you so much. Hey,
With,
you know
with
what?
the number of zeros being basically the whole number, and like the number of
Go for
zeros
it,
plus
yeah.
one would be the number in base 10. Oh wait, no, you can't have anything.
Hey, you guys discuss this, okay? I'm actually trying to figure out a way in which I can get a view of myself also on screen. So don't bother and talk about this. This is actually a very interesting discussion, okay? And it's going to be on Zoom. You guys can watch this discussion later too. I'm just trying to figure out a good side-by-side gallery here. Go ahead. Why is the silence now? So Sanatan was saying, if it was unary, you would basically just have a string of zeros. It's just one symbol, one after another, right? If I wanted to say 5, you'd say 0, 0, 0, 0, 0. Yeah? In fact, we use that system, I think this is it, right? Tally marks. This is tally marks is a unary system, right? This is a 1, 1, 1. Actually, the ancient Roman Roman number system was unary, isn't it? 1, 1, 1, 1. And you know, tally mark, it gets difficult to count after a while. So that's why you say four of those, and then you cross them through. How many of you actually done tally marks? You know, in your I think maybe elementary school. Yeah, thank you, Adam. Right. So because when you have to build, I think histograms or count things, you basically do tallies. It's a lot easier than just doing those things because you can't count the numbers as easily. In fact, that is one of the things that we'll use in programming, you know, in our code style later on, because sometimes when we write loops, and in our loops, we have to say the number 1 million. Okay, 1 0 0 0 0 0 0. We actually do something really strange there. And a lot of CS2A students are perplexed. Instead of saying 1 million, we actually say 1,000 times 1,000. And in fact, what happens is a compiler in C++, okay? Maybe not in other languages. In C++, it has to be compiled. The program has to be compiled and turned into machine code. That compiler, before turning it into machine code, will turn the 1,000 times 1,000 into 1 million. So, you know, the runtime system, when you run the program, it's not running any slower. However, it's become easier for humans to read. Do you understand? Do you agree with that? Anyway, this will all make a lot more sense. When we start cutting code and you actually see examples of this in action, you can actually see, well, you know, that is why. All right, and we'll talk about all of these things too at that point. Okay, so for now, I think, yeah, you know, Faith, or who was it? Mitchell or someone was about to read off a 7-digit binary number. You know, just pull digits out of thin air. It does, you don't have to just pull out digits and just call them out. 9 of those, right? One after another. And that is our number. And we want to convert that number into decimal. Okay. We want to convert that number into decimal, right? And maybe after, you know, actually I lost Ryan now. He's not even here on screen.
What, do I have to
Anyway,
talk or something to be on
yeah,
your
now
screen?
you're here, but I can't see myself.
Okay.
You know, I don't even know if I'm on screen actually. Hey, I must be there somewhere. Okay. All right. So Chris, you're going to be doing exactly the same thing. Whatever number. Well, you know, where is someone? I don't know who was going to call out the number. I said Faith, but Faith is not here anymore. You know, these orders changed because maybe I was fiddling with those, right? How about Caitlin? Okay, Caitlin, you're going to call out a 9-digit number. Yeah, 9-digit binary number. Basically just ones and zeros, and you know, no specific pattern, just random numbers. Okay, and if someone butts in and they change it to
Was it 7 digits or 9 digits?
let's do 7. Okay. Let's just thank you. I actually meant 7, and I think it was and increase the font size. Hey, Ryan, increase the font size or hit Control plus, Command plus, and so that, you know, we'll actually see how the conversions happen and so on. Now, this is just a PC, right? You can only type, you can't write.
Yeah.
Yeah. That's okay. That's okay. If anyone has an iPad or something and they can zoom in from an iPad in a second session, that's okay too, right? So then you can actually write too. We've had people do that in the past. So. All right, so you can write down whatever Caitlin is saying, and then you're going to convert that from binary into decimal. How many of you have already read the module, by the way, right? So a few people have. Now, if anybody is unsure, or even if Ryan is unsure, that is okay. That is absolutely fine. All we're going to do is that we're going to do exactly what the module will also say you have to do. So basically, after doing this, when you go home and read the module, you'll say, hey, you know, that's what we did in class. You just remember it. Well, you know, I think the module does a pretty decent job of describing it too. But just in case, you know, for some people, the lecture thing works better. All right, so that's what we're going to do. So Caitlin, go ahead and call out the number, and then Ryan is going to convert that number from binary to decimal. Right?
Okay, 1101,001. That's 7, right? Okay.
Okay, Ryan, are you able to convert it, or would you like me to walk you through this? Okay, how many of you would like me to walk Ryan through this? Because remember now, Josh, who's on my screen next, right? So I don't know where actually, you know what? There's got to be some setting somewhere that says, the host screen order. It's shuffling the all of the rectangles around, so it's hard for me to at the point in time, whoever happens to be next, right? So
There's a
this-
list of participants.
Hmm?
You can click a list of participants on Zoom.
Oh, I can just I can go by the text. Yeah. Thank you so much. Thank you. Didn't even. There you go. Much better. But this is in alphabetical order. We're kind of disincentivize people from joining soon, I think. Hang on one sec, okay? Just one sec. All right. It is in alphabetical order. I didn't want to do it alphabetically because students who are what I wanted. So here's what I want, okay? And you guys should somehow configure these things in such a way this works out in all the future classes, okay? Whoever is least confident about whatever it is we're talking about in class, okay? So in other words, if the next person after Chris is going to be Caitlin, okay? And I say, Caitlin, you're going to have to do the same thing in 5 minutes. Caitlin could say, no, I know how to do this. I've read the module. I'll pass on this opportunity, okay? So you should feel free to say that. Then it'll be okay for us to do it alphabetically. Then I can just go off the participants list. Then everybody will have a chance. Because, and it's not like if you know how to do this and you're going to pass on the opportunity, you're not going to get an opportunity later on, okay? Maybe you'll get an opportunity and the very next thing we do. Maybe in the last 10 minutes of this class, today's class, if people want, I would like to just do a screen share with one of you on how to go about submitting the very first quest, because I think there's a lot of people hung up on that, and it'll be a pity not to be able to progress in your homework just because you haven't broken the ice. So, and it's like 2 minutes really to submit the first quest and get the trophies for it, and I'll walk you through that, and it'll be in the Zoom. It's the last 10 minutes. Okay, if not, I'm pretty sure there's videos on YouTube from past students. You can actually ask on the Reddit too and say, hey, how do I do the very first question? Can someone give me some tips? And I'm pretty sure someone will say, hey, this is what you do, right? They might even share a video. If not, we'll do a demo in class. Okay, so here's what we're going to do. Right now we have Ryan. Yeah, we have Ryan who is going to convert. Ryan, do you want me to walk you through this?
Yeah, could you do that, please?
Okay. All right, great. So here's what we're going to do. Everybody pay attention because I have next, Chris, you're going to do exactly the same thing. And hopefully I will not have to walk you through this, okay? Maybe you'll get stuck. And if you get stuck, I'll, pull you out. I'll say, hey, all right. So you don't have to worry about anything, but I won't be walking you through it step by step. And in fact, what I'll do is when you get stuck, I'll actually wait for someone else to pull you out before I jump in. Yeah, how about that? So everybody will get a chance to chime in. And then for the next person, maybe Caitlin, or maybe Caitlin passes and it goes to Jacob, and Jacob maybe passes, Rui, and so on and so forth. And they will do exactly the same thing with, less and less of me and more of you, right? I think that'll be cool. Along the way, what I'll do is I'll watch this because it is experimental for me too. I'll watch this and I'll say, all right, now let's say Alan is passing it on to Ava. And I'll say, okay, well, now let's just spice it up a little bit more, right? Because I think that, okay, it's getting too easy. Now I'll say, okay, now let's go from this to some other base, like octal or something like that. Hopefully today, by the end of today, we would be able to tackle, base 27 conversion, okay, base 27, which is really take your name, like it has to be most of your names are short, but we actually had people with long names, even hyphenated names, and that would in class, when I taught in class, There's one person with a hyphenated name and said, how do I convert my name from this to hexadecimal or decimal? Say, hey, that's fine. You got to take the first part and the second part and subtract the first part from the second part in base 27 because there's a hyphen between them. All right. So, and that, I think that'll be really cool. If someone has a name like that, we'll try and play with the name and convert that. And this is a very good exercise in, all right, I do that and then you do that and everybody gets to do that. Maybe the same name or maybe their own name, whatever it is, and convert that from, base 27 representation to decimal and understand all the steps along the way. Everybody does that. Then there are 5 questions, not 5 questions, but 15 points in the data representation quiz. Hopefully, not all of you have taken the quiz already, but I think there are 15 points, I think, where you will be given a phrase in English and asked to assume that each word is actually a number in base 27 and convert it to hexadecimal or something like that. Okay. It's such a long time since I created those questions. I've actually forgotten, but I think it was fun. Right. So, but there's a lot of points there, learning to convert from one base to another. And so today, that's all we're going to do. Base conversions. Next class on Thursday, I'm hoping you will all have read through the remaining parts of the data representation module, which deal with how we represent negative numbers, right? This is sign magnitude notation and 2's complement notation. 2's complement is what a lot of people have. In fact, we can talk about 2's complement today too, if you guys, are up for it. And then floating point notation. That's all. Okay. From next week onwards, which is going to start coding. Coding is a lot of fun. I think a lot of people want to get into it sooner and sooner. In other classes, actually, I'm the only professor who teaches data representation in the programming class for the first week, first 2 lectures. In all of the other classes, CS1A, 3A, they just jump right into coding on day 1. Maybe because I don't know, even in C it was like that before I came. But I think in the other languages it makes more sense, because in C you need to have a solid understanding of the data representation at the bit level in order to leverage the full power of C, because otherwise you're just being a Python programmer in C, right? So even if you're a kick-ass Python programmer and develop some really cool stuff, at the end of the day, when it goes to production code, when you deploy it out there, you can't afford to run it in Python, right? Python is good for proof of concept and a lot of these things, but a heavy-duty crunching has to happen in C, or assembler or some really powerful language that doesn't leave a lot of things out to chance and garbage collectors, right? So everything you take care of. So that is why I think C is a very good choice as a first language to learn, because I think more than anything else, it builds the grit and the discipline needed to learn a language properly, rather than just understand it at a hand wavy level. You actually get to learn and I think, why is it important at all to learn programming these days, today, right? So I can say with 100%, total confidence here, right? In a few years from now, programming for money is not going to be a thing, right? It's because anything you want to get written, you can get written by a machine. So yeah, people are not going to pay you to get write production code or even write code at all. So, but does that mean that people will start learning to program, or start learning, stop learning, saying, I don't want to learn to program because machines can do that? If machines can do that, suppose I were to tell you, I've found the secret of the meaning of life, right? So that's it. And suppose you believe me, are you going to stop finding the meaning of life yourself? No, everybody has to do that themselves, right? Just because someone's done some great piece of art out there doesn't mean that you're not going to do it. You're going to do it too. So I think in a few years, programming will still be there. And people will pursue programming, but as a pure art form, just like it should be, like even science or anything that humans do today, and they're getting paid for. We will get a chance to now explore just for the sake of that thing in a few years, because machines will take over the rote aspect of everything, pretty much, right? And so that we can enjoy being humans more. And so programming that is why learning to program in C, I think, actually goes down to that level. It is not to learn to do something or build something, because all of that can be done for us much more cheaply than stupid humans can do it. Yes, but why is it that we learn to program? It is because doesn't have to be C++, doesn't have to be this, and in fact, this can be learned in other fields too, in science, in even in arts, right? It can be learned. But I think the mathematical sciences, especially in STEM, predispose you or push you more in the direction of developing that kind of thinking. Okay, that kind of critical thinking. Objective critical thinking is so razor sharp and saying this is right and that's wrong, and I have a certain intuition about it, and that's how I can prove it, because it can be both or something like that, right? So that kind of thinking, people say, I don't know, it comes naturally and so on, but I can tell you with 100% certainty that if you are at it for a long enough time, it just seems to come naturally. But it's not natural, it just comes out of practice. It is because everybody has it in them naturally to be incisive and curious and discriminatory. But I think what's happening is that we're not getting an opportunity to sharpen that blade often. Many times we just get by with loose stuff, and so we're not having to push through and sharpen that. I think, I don't know, the programming in a mathematical sense push you in that direction, saying I need to know. I'm not afraid. I'm not satisfied with hand wavy truths, right? I need to know, and asking question incessantly until you're convinced. So that is why programming, whether it's in C++ or any other language, is so important, even if machines can do the programming for us, I think, is because it helps you attain the mindset sooner than other art forms, I think. I may be wrong here, okay? Other art forms, just by developing the grit and saying, I need to get to the bottom of this, and because I have a clear-cut notion. Maybe that's what it is, right? So in computers, in these sciences, we have a clear-cut notion. Actually, less so in physics, and the more empirical a science gets, the less fuzzy the decision becomes, right? Because you get towards computer science and math, the decisions can be razor sharp. The further away from math and computer science you are, the softer the decisions become, right? Until you get to the soft sciences where you have to make subjective decisions altogether, right? But here, that is why I think it is good for machine learning and training our minds, right? That is why the mathematical sciences are good to train our own mental neural nets, because the examples provided, the training examples provided from life, as seen through the lens of math or computer science, have a very good signal to noise ratio, saying this is definitely a positive example, that's definitely a negative example, right? So if I don't know, right, some of you will be going on to do machine learning, for fun maybe, right? And you come across things like positive examples and negative examples. What are they, right? A positive example is something that you want the machine to emulate and say, hey, and you attach a reward to it, saying that's a +1. A negative example saying, don't do this, that's a -1. And then you feed lots and lots of these examples, and statistically, the weights in some neural network, we'll look at all these examples and adjust their values so that when you see something that's unseen before, the weights will fire in such a way that, hey, that's more likely to be positive, that's more likely to be negative, right? So that is the learning aspect of it. And that I think, I'm sorry. Yeah, I didn't mean to launch off into this digression, but all right. So I want to come back to the thing about converting from binary to decimal. Okay, so in binary, in decimal, if you think about a number, you say a number like 543, right? 543. If you look at the number, all we're saying is that, well, you know what, the fact that we have the symbols 5, 3, and 4 and things like that's totally coincidental, right? Some dude came up with these symbols and we use these symbols, right? But what we really mean is that that is the number of ones in it, that's the number of tens in it, that's the number of hundreds in it, right? There's a 5 of the hundreds, there's 3 of the tens, there's 4 of the ones. Yeah, but if you look at what the quantities we're looking at, hundreds and the tens and the ones, they're actually just powers of 10, right? 10 to the 0 is a 1, that's a units column, right? 10 to the 1 is a 10, that's a tens column. 10 to the 2 is 100, right? So 534, right? 5 times 10 to the 2, 3 times 10 to the 1, plus 4 times 10 to the 0. Yes or no? right? So I need to see a show of hands or something here so that I can proceed to the next stage, right? So yes or no, right? So Caitlin's nodding her head, but at least, of the other people that I'm looking at, the funny thing is, yeah, thank you, Chris. Thank you. Right? Yeah. Actually, the thumbs up on the thing also helps. The funny thing is, if I have this participant list on all the time, it actually takes up a lot of the real estate. And as it is, the font is pretty small. So I'm going to close the participant list. The next person is Chris anyway. All right, I'll open it up at that time. Yeah, that's much better. All right, so I'm seeing a couple of, thumbs up, which means you kind of understand. But if any of you have questions, right? Those are the ones who should speak up. So the ones who say thumbs up, I understand it. Yeah, okay, all right. You all understand it. But the job of the instructor or the job of the professor is not to teach the people who understand it. Okay, that's the easy job, right? We get to paid for the hard job, which is to make sure that everybody is on the same page. Okay. So that is why sometimes when we deal with some of the stuff later on in the future lectures too, some things may be very obvious to some of you, maybe even the person that's coding, but we'll have to take it slow sometimes because we want to make sure that everybody is on board. Okay. And by the way, Tuesdays and Thursdays are when we have our classes. But last quarter, I think some of the students benefited from having a virtual Zoom meeting time. I know, right? I actually didn't understand. I didn't attend many of these meetings, but the students actually got together on Zoom, but I had to set it up. So if you guys want another hour, anytime, right? Pick a time and say, set up a Zoom meeting for us. I'll be happy to do that. And you guys can just hop on the Zoom whenever it's ready, whenever it's time. You help each other out, not by sharing code or looking at each other's code, but someone could say, hey, you know what, I'm trying to do this quest and it's bringing 2 extra lines. What's going on, right? And you don't have to look at their code, and you can also develop the skill. This is a very useful skill of trying to figure out what's wrong in the code without looking at it, right? A lot of people take a shortcut when someone says, something is not working, saying, let me look at the code and say what's not working. Yeah, okay, it's shortcut. But it's actually the bigger part of the puzzle is to actually figure out what's in the code and what the code looks like by what the person is saying. And that's actually a useful skill, not just in computer science, right? Even if you want to be a talk show host later on YouTube, right? Actually figuring out what the person is trying to say and then getting to it is actually great, right? Because you can actually make the person say what it is they want to say, even without them saying it, like that. All right. So here is what it is. What we want to do here is instead of 10, we're going to take base 2. That is why it's binary, base 2, right? So starting from the right side, and you can have discussions on Reddit on why it is starting on the right, not on the left. Maybe there's historical reasons, maybe there's aesthetic reasons behind them. And you don't look at Wikipedia and don't look at the history. This is some bullshit, okay? So, this is there's a question. You can basically say, I don't know, right? Maybe there's 100 publications out there that already say this is how you do it. But that doesn't mean that we're not going to try and understand how to do it. And we don't want to try and understand how to do it by reading them, right? So it should be, because those people had the joy of eating that cake. Yeah, why should you not have the joy of eating that cake too? And so that person tried to solve this puzzle the first time, right? So then you say, hey, that person had a great time solving it. I'm going to try and solve it too. Rather than say, well, you know what, let me see what that person did. That's no fun. So you should also take the more fun approach, really, in all of these cases. So don't look up the net. Don't look at the past subreddit, okay? Because every single problem you face on the Reddits is even worse than Chegg, I think, right? So you go to Chegg and say, this assignment in, this university, 12.7 or something like that. And they give you the answer. Not Chegg or some of these websites. Really, you don't even need, because, with all these agents coming up, you don't need, plagiarism websites even sometimes, right? Because, in a few years, teaching is even not going to look like this. Totally. This is a total, I am a relic from the past, really, if you think about it. Because even as it is, there's enough videos of me teaching CS2A on YouTube, right? And all the content out there. So you can actually create an AI version that in whatever that Apple thing is, that, immersive, and sits in front of you and teaches you in a style that is, looks like me and teaches in a style that works for you. And that is a personalized virtual tutors that is available to everyone. And companies like, colleges like Foothill and so on, they will all be using the same data essentially, right? So I don't think there'll be any distinction between top colleges and bottom colleges anymore, because all of the data is curated and out there as one central repo, and which feeds all of the virtual tutors in the world, right? Of which there could be millions, right? So all you need to do is just put on these glasses, or maybe it's contact lenses, right? And right in front of you, your personalized tutor appears, and they could walk you through the problem at your pace, right? Like, like questing in many ways. So and picking problems that appeal to you from your personal life, all of these things, that'll become, very common in future. And, as little as 5 or 10 years from now. That's so all of I'm retiring sooner maybe than that could happen, but it could happen even before I retire, right? So it is a great time to see this unfold. So here's what we're trying to do. So instead of base 10, we're to base 2, right? So the rightmost digit is base number is 2 to the 0. The next one tells you how many 2 to the 1s there are. The next one tells you how many 2 to the 2s there are. So Ryan, you can just move your mouse over the rightmost one. That's the 2 to the 1. Yeah.
Yeah.
Oh, this is my mouse, is it? All right, I see. Oh, so you get the cursor, not the mouse. Oh, you got the thin mouse. All right. So yeah. So on the rightmost digit is 2 to the 0. That's 1.
Mhm.
Then 2 to the 1. That's 2. 4, 8, 16, right? You sum up all of those numbers, you get the decimal, okay? That's all very simple. So we'll do that, and then we'll also do one more really quick thing of converting that number back into binary, yeah? And then Chris will take over, erase the whole thing. Well, you have to remember the number. Oh, we'll come up with a different number, okay? Chris will take over another number, and he's got to do exactly the same thing, okay? Is everybody okay with this? And then we'll try and repeat this as many times as possible. Well, you know what? But we did want to do other things. Just converting these numbers. And maybe there's other things that we want to do. There's hexadecimal. Actually, 2's complement. Well, maybe we can try and get to 2's complement too. But the thing is, most of you saying are saying you haven't read module 0 yet. Now, it's very important to read module 0, because a lot of the stuff that we're going to talk about today, like 2's complement and so on, this is what we're doing today, right now here. It's like the first couple of pages of module 0. This is 16 pages in all, I think. I used a big font, wide, big space, lots of spacing between lines, and but still, this is the basic stuff. And then I think we talk about 2's complement, ways in which you can represent negative numbers, negative numbers, and so on. Once we understand how to represent information, so that is all there is to computer science, right? Once you understand what actually is going on, it's actually very simple. What we need essentially is some way of consistently representing information from one form to another, being able to change if it's not lossy, right? So from, if it's an image, right? How do you represent it on a computer in ones and zeros? Well, you can basically strip, make little strips of, cut it into little strips, and then strips into dots, yeah? And then all the dots, just like a jigsaw puzzle or something like that. And each dot is a number. And then you create a large matrix or a large sequence of numbers that represents this image. Hey, now it doesn't look like the image, but it is the image, isn't it? Because the image has actually been cut into a lot of dots, and each dot has a number associated with it. If it's completely white, it's 0. If it's completely white, maybe it's 256 all once, which you'll come to very soon, right? If it's completely 0, it's black, and numbers in between are shades of gray. So if you just cut up a picture into lots and lots of dots, right, and say that is dot number 0, 0, the next one is 0, the first 0 is the 0th row, the first column 0, 1, 0, 2, 0, 3, and so on and so forth, right? You have all and you basically take all those numbers and put them out there one after another. You get a long stream of numbers. That is basically a representation of the image. Yes or no, right? Well, however, some information is lost there. These are all interesting points for discussion in the Reddit. So you can talk about this in the Reddit and say, hey, I took this picture and I, moved it over there in dots. What is the information that's lost? Well, we don't know the size of the picture, right? Or it's a regular picture, or it's a square, or so on and so forth. So those are things that are interesting you can talk about. Basically, ways in which you can take information and digitize it. That is the underlying theme for the entire week, okay? So let's not even talk about programming. Next week, we'll talk about programming, because once we know how data is represented, then we'll talk about ways in which we can take that data and change it. Because here, the aim of computer science, essentially, in C++, this class, is really how can we take data and how can we change data? Now, if I have data out here on my desk or table, I can change and move things around. But it's very, it's a very coarse and big representation. But you can take this, some of this data, condense it out into electrons, and store it in bits or switches, electronic switches that are so tiny, right? On means 1 and off means 0. So you only have two states, 1 and 0, right? So can you just use 1 and 0 to encode everything in the world? Everything in the world. Technically, everything in the universe, everything in a finite universe, can we store just using ones and zeros? Yes, you can, right? Theoretically, you can. Now, again, interesting discussion point, right? You can talk about this in the forum and say, hey, is it possible, right? And what are the limits, of this thing and so on, right? Again, all of these things that we talk about in class, like slight digressions, like bits and bytes, and then there's a slight digression there. Just make a note of this, because these are all interesting points for you to bring up in the Reddit and talk about. You'll get your points at the end of the week. You'll get participation points. But just picking up, hey, during the last class we talked about something, numbers, and can you represent any data type as a number, as a number, by the way, right? Not even binary number, because once you get it to binary, it's just a decimal. Right now we're going to do that, right? We're going to convert that into a decimal number, right? A number that we're all used to. We're going to convert that. So once you get into binary, you can convert to decimal. So what you're saying is that give me any picture, right? A picture of Manuel looking there, right? With his baseball cap and all. I got a rectangle. Now I can convert that into a number, just a number, one number. And how can I do that? All I have to do is, take that entire picture, cut it up into really, really tiny dots. Yeah, maybe 1,000 by 1,000, right? That's not even tiny these days, right? 1,000 by 1,000, so it's 1,000,000 dots there, right? And each dot will have a number between 0 and 255, indicating its color, right? And so I just need to take 0 to 255 is basically 8 bits, as we'll see, 8 bits. So I take 8 bits and put it on, on somewhere. Okay, and then I take the next dot, 8 more bits, put it there. So in the end, I'll have lots and lots of bits. Okay, but it's just a stream of bits. I can get one number from my stream of bits. Yeah, and so that number is Manuel, right? But that picture of Manuel is that number. So that is the way you serialize. It's called serialization. Serialization meaning, right? If I had to transmit something over a line, it has to be sent in serial mode, one after another, or one bit after another. This picture is like instant, bam, like that. But if you serialize the picture, I can't send it bam like that. I got to take that and spaghettify it and send it through one bit at a time. That is called serialization. So you'll get to do a lot of that in this class, okay? In this course, as you get to CS2C anyway, because what happens is that right now we're just building elementary data structures. In later on after week 4, okay, we're building elementary data structures, integers, linked lists, and so on and so forth. Easy to visualize. But when you get to building more advanced data structures, sometimes it is very useful to see what it looks like, right? In order to see what it looks like, you need or debug it, you need to have representation, because you can debug things in virtual space. You can't even see it anymore, right? There's structural errors in something that you can't see. It's really hard to say, figure out. So you need to represent, you have to show it on screen. But in order to show it on screen, you got to take that virtual structure that is just basically a bunch of connections of numbers and connections to each other. And you got to show that on screen. And you got to depict that on screen using numbers and arrows and things like that. So that process is called serialization, because you're taking that and sending it to your console one at a time, saying put that in that column, put this character in this column, and so on and so forth, and you paint that on the screen. The serialization. So isn't it a fancy word for today? It's not even in the it's not in the I think it's in the syllabus, but it's not in a requirement for today. But you'll come across this later on, especially since you're going to be doing a lot of this in question number 6 onwards. Okay, from question number 6 onwards, you'll be doing serialization, and which actually will getting good at that is really, really good, because any of the advanced projects that you will be getting into, in your life as a programmer, whether for hobby or creative works, or or for working for other companies in the next few years, right? Until your job gets automated. So you can actually look at your data. When you debug your code, you'll actually be able to get that skill of saying, well, you know what, I want to know what's going on. Even if you're working on some of our algorithms in CS2C, it's very hard to get it right until you actually draw it out on a piece of paper, right? Not even on screen. There are fancy visualization tools. You can actually take a binary tree or a heap and put it in some website, and I'll show you a picture, a 3D picture of that of the data structure. You can rotate it and look at the connections and see what's going on. But even without that, you don't need that to understand some of our algorithms. That's what I mean. Okay, a lot of people can get carried away, but what you can do is when you get to some of these problems, a notebook and a pencil. Okay, best friend for a programmer. So just draw a picture of what you're trying to do. A lot of people just miss that, and they spend countless hours in front of a computer. Okay, and I've seen students, right? When I was teaching, I used to go to the STEM center, and they were poring over the computer for a long time on at a bug. But it'll just take them a minute if they just try and do it on a piece of paper. For some reason, I just think that computers can solve everything. But once you get to draw it out, it'll make a lot more sense. All of these are valuable from the perspective of getting participation points too, and it also helps seal in the knowledge that you get, right? And again, I can't emphasize enough how the knowledge of these two lectures, the first week, are going to help you later on in this class. Even in 2 weeks down the line, when you're making loops, trying to make the loop stop at the right time and all, you need to know what the data types are, right? So whether it's signed or unsigned. So that stuff you need to understand before Thursday. Thursday's class, when you come, we'll be working through problems, and I won't be, spending so much background, giving you any background material like this, hopefully. But you will get a chance to convert numbers from explore more. Let's put it that way, right? What a signed number is, what is different? What is the difference between a signed number and an unsigned number? These are things you can get into in the forums too, even before Thursday, right? You can get into and ask signed number, unsigned. Well, how does C++ distinguish? In other languages, you don't get a chance, right? You don't get a choice. In Java, for example, you just get one kind of integer. I don't know, maybe you get a big integer. I haven't programmed in Java for such a long time. I don't know. The latest Java maybe gives you the opportunity. But you only get one kind of integer. In C++, you get so many kinds of integers, and it is not like overkill, right? People say, well, I don't need to know that level of detail. No, you actually need to know that level of detail if you want to cut every single cycle out of your CPU and make your program as lean and mean as possible. And it is actually useful to know that, because that kind of thinking is what will get you through many things, not just in programming, even in life. So yeah, that's what I mean, right? So learning to program is going to be important, because it helps you get to the place of independent critical thinking sooner than many other fields. Generally the mathematical sciences, or if not, at least in the STEM area, I think, right? I don't know, because it kind of puts it front and center. You got to get it right, or else you're doomed essentially in these areas. Yes. So that is why it's very important in programming to get a sense for doing these things, right? So how about for now, I'll just ease off, right? No talking anymore from me until you ask me to. So how about now, Ryan, you're going to go and work through, I don't know how you're going to do this on here. You're going to work through this thing and get the decimal value of this, right? So I must have spent like 15 minutes talking, or half an hour. It's crazy.
So should I like explain it while I do it, or just do it?
Totally. Thank you, John. Thank you, Ryan. Okay, because if it was silent, I would have said, yeah, please do. Always keep the airways
Okay.
occupied. Okay, always keep the airways occupied. If I'm not talking, someone else should be talking. Right now, maybe it's not so much of a big deal, but later on when you're coding, I might say, code this, right? And I'll step away, or even away from the screen. You got to be talking. It's like super duper important. I don't know, because if no talking and just characters appearing, if, then, else, and so on, people just switch off, right? If you're talking, like Ryan said he was going to do, people will listen. And we're going to put these up on our Zoom site for other students, maybe not future students, but at least, the guys who missed the lecture with valid costs, right? They email me and say, can't make it. They'll be able to benefit from it. Thank you, Ryan. Okay. So I'm just going to,
Okay. Yeah.
thanks.
Okay, so starting from the right, it's first is 2 to the power of 0. So we know that anything to the power of 0 is 1. And then you have to multiply 1 by 1 because it's a 1 here, right? And then the next one is 2 to the power of 1, which is equal to 2. And since 2 times 0 is 0. And this is 1. Okay. So we're on the third one. So that should be 2 to the power of 2, which equals to 4. And then it's also a 0. So 4 times 0 is still equals 0. And for this one, it's 2 to the power of 3, which equals 8. And then 8 times, it's a 1 here, so that equals to 8. And then 2 to the power of 4 equals 16. And then 16 times 0 equals 0. 2 to the power of 5 equals to 32. And 32 times 1 equals 32. And 2 to the power of 6 equals to 64. 64 times 1 equals 64. And then we just add all these up, I think, right? So 1 plus 8 plus 32 plus 64, that equals to, let's see, 9 plus 32 plus 64, which equals to 41 plus 64, which equals to 105, I think.
That checks out, I think.
Yep. So yeah, I guess that's done. Professor, was
Great.
there anything I had to do after that?
That's fantastic. Yeah, well, I think it'll be, the next person is Chris, but however, before we do that, why don't we convert 105 back to binary, right? Does anybody know how to do that? I can, so we'll do that really quickly, and then the next person can take over and do the exact same thing. Is that okay? We'll do it on the next line. Hey, Sanatan, you got a question?
No, I thought you were looking for volunteers.
Okay. Hey, oh, your hand was raised. Alan, you got your hand raised too.
Yeah, just to make sure. So, you said we have to go from like the right-hand side to the left-hand side. For translating the number.
Yeah.
Yeah.
It's a
Okay.
very interesting question. Yeah. Why do we need to go from right to left? Because, in English, when you read English letters or English books, you go from left to right. Yeah. Most Western languages, we go from left to right. However, for the numbers, we go from right to left. So why is that? That's a very interesting thing, right? So you can talk about that. You can think about that. Which is more intuitive, which is more aesthetically pleasing, right? Maybe there's a historical reason for it, right? There is actually a historical reason for it. But even if there was a historical reason for it, yeah, maybe there are aesthetic reasons too. So you can think about these things, talk about these things in the forums. And without, that is interesting. Yeah. Forget about Arabic numerals and Hindu, the thing, the script, the thing that was discovered in Gujarat and things like that. No, forget about that. Just talk about the aesthetics. The interesting thing is that if we don't look up the past, or including Reddit, any of the information, Wikipedia, and so on, some of the things that students come up with are actually incredible, right? Because some of the solutions I've seen, some of the explanations I've seen from students who actually just came off, saw the question on Reddit and responded without actually having the time to go through and research the answer. Actually, they were actually quite brilliant, right? I forget them, but some of them are more interesting than what I would see in Wikipedia sometimes, right? So I think what happens is that if you just go for the solution straight away, like you're entitled to, or you're spoiled, and so every time you want something, you get it immediately. right? Then you can't defer the gratification of saying with the puzzle or saying I'm going to sleep over the problem, saying I'm not cut out to be a mathematician or a computer scientist. So and I'm going to go to sleep with that in my mind. Okay, so that's a pretty harsh thing, right? But if you can stomach that, the next day you may feel that no, actually that was actually quite simple. Why did it keep me from it, right? But the thing is, what we do is that we can't stomach that and say, well, rather than go to bed thinking I can't do that, I'm going to look up the solution. So just don't do it, even if it's free state. Yeah, okay. Say I'm going to eat the -5 points for the late quest, but I'm not going to look up the past Reddit or find someone's answer to it. It's okay, and you'll find it actually does help a great deal, because the more you struggle in the early quests, you'll be surprised. It saves you a great deal of struggle in the later quests. And in fact, I found that in my 2B, everybody has to do all the blue quests. Okay, this is basic stuff. Everybody has to know all the basic stuff before you go on an intermediate level. So I tell my 2B students to do 2A also, and some of them actually do work through all of the blue quests, and I can see them. I get real-time updates and notifications and so on, so I know when everyone is people are working hard, and I know every single point they're eking out and how many minutes elapse between the points they get. So all of that information is fed into my system, and I get summaries of all of these things. But also what happens is that sometimes people who enroll in 2B, they enroll at the last minute, and they have to, and they didn't do all of the quests, but they get the solution somehow. Maybe ChatGPT, or I don't know, maybe they get it somehow. I'm pretty sure every single problem out there, every single problem any school has published, right? Stanford, Harvard, whatever it is, so solutions out there on YouTube, whatever it is, right? So the onus really falls on the student, and saying, how can the student learn despite being offered free solutions around every single corner? So you got to say that I'm not in it to make a buck. I'm not in it to make fame, glory, or any of these other material things that are ordinary people are after all the time. I want to know something that is much deeper. So I want to know why this is done this way. And then you say that is the value you get for the fees you pay at a university. Not the piece of paper that tells you, hey, here's a certificate, go ahead. And that's your, claim to knowledge. You can get that anywhere. Maybe it costs $100,000, maybe it costs $100. But it's not worth nothing at all. But what you actually paid the money for is the knowledge. And there are people in all of these places that actually know their shit. But the thing is, students sometimes seem to gravitate towards the people that are easy to get, through the gate, right? Or, pass through, rather than the people that will actually stop them and say, you're not going through until you actually know the material. And I think the one possible reason for that is saying, well, you know what, my future is not here. My future is elsewhere. So I just need to get through here so that I can go there and make my splash. And that is a dangerous attitude, because the time you make your splash will just keep getting pushed out forever and ever and ever. You will never reach it, right? Whether it's the next university, or maybe it doesn't work out at my next great university, I'm going to go make a startup, or convince the VC, or whatever it is. It'll just keep changing on and on. Pretty soon you would have squandered your opportunity. Right now you're a student, and you got all the time in the world, and you got the freedom to make mistakes, which you don't get after you're employed, right? If people are paying you money, you can't afford to go wrong, right? Because it's their money you're going wrong on. Right now, it's not even, it's generally it's a taxpayer's money, right? Because the community wants everybody to be knowledgeable and educated. So really, the tax that we pay, I pay, you pay, right? The mom and dad, all of these people, they pay taxes, because that money goes to fund places like these universities that get people educated. And that is where all of this is coming from. And so you've actually paid the money, and the best thing to do is to actually say, all right, people have paid money for me to make mistakes. That is what it is. When you're at a college or a school, you get sent to a school, that it means that for the first time in your life, right, you never were allowed to make mistakes as a kid, maybe, right? You can't make mistakes when you're working for someone else. But during these 4 years or 5 years you're here, this is your greatest chance to make mistakes, as many mistakes as possible, right? Not, fatal mistakes, stupid mistakes like getting into drugs or something that's, going to harm you in the long run. No, but there are lots of places where you can make great, healthy mistakes, right? And then this is a place for it. Don't just be mindful of your future and not ruin it forever. And there's so many great things you can do, and say, I'm going to try this, I'm going to try this new field. and see if it works out for me. But you can't say there's a billion things here, and if you say I'm going to give every single faculty here, every single department at Foothill a chance, then you can spend your 4 years or however long you're going to be here. You can sample every single thing here, and in the end, you'll just be a jack of all trades. You won't really have mastery, right? So you have only limited time. You got to put that to good use. That's why it means what that means is that you got to determine very quickly the window of time you have to determine the area that you're most likely to be fruitful and enjoy a lot is not like 2 years. You got just a little bit of time, and don't say that I just need to go through so that I can go somewhere else, and that's not it. Any place you're at that moment is the place you're best at any time, right? So treat this as the best opportunity you have, right? And seek out people at Foothill. There are incredible resources, right? I sent the thing about the STEM Center too. The funny thing is I'm not here on the screen at all. Why is it? I'm not even in the. Can you guys see me? Am I on screen? I'm not here,
Yeah,
right?
yeah, I can
Yeah,
see
you at the bottom on my screen. You at
I
the
am?
bottom.
I'm not
I
even
think you
here.
can add a pin to yourself. If you press the 3 dots, you can pin yourself.
Yeah, okay, I'll figure it out later. I'll figure it out later. Well, as long as you guys can see me. Well, actually, maybe it doesn't even matter. Yeah. I don't know what I was talking about. But essentially, let's go ahead and convert that back from 105 into binary. Yeah. And the trick here, I'm gonna show you what is called an algorithm. An algorithm is something that is a procedure that will eventually terminate and give you the answer. We'll go into the more detailed definitions later on. But algorithm is basically a mindless. That is what it is. Okay. That is the basic idea behind an algorithm. An algorithm is a sequence of steps that, if followed by a mindless person, an automaton, right, doesn't have anything else to do, doesn't have a life to be, experienced. So that person can do it forever, 24/7, all the time, every single second, right? So you keep doing that repeatedly, it will get us what we want eventually, right? Now, if it's going to keep doing that and never get what we want, that's not an algorithm. Yes? So an algorithm is a process, a procedure, which you can keep doing repeatedly, or maybe not even repeatedly, but it's a sequence of steps. At the end of it, you'll have what you want, okay? We'll use that as a rough definition of what an algorithm is. So for this, I will teach you, right? So one way in which you can do it, but I'm not going to show you the intuition, right? This is because the intuition behind this is very simple. You can figure it out yourself. There's a bunch of videos. Actually, there was a video that I shared on Canvas in modules, but I'm pretty sure I made sure to unpublish it, okay? Because it's interesting and it's cool, but it kind of lets the cat out of the bag, as it were, right? It's because it's an interesting intuition behind it. It's useful for you to actually figure it out yourself, and it's actually fun for you to figure it out yourself rather than watch the video. So I'm going to show you how it's done, but you figure out why it works. Okay, why the hell does it work, and then talk about it in the forums. Okay, I think it'll be interesting. Okay, so what we're going to do is essentially divide 105 by 2 repeatedly, right? So on the next line, Ryan, and actually, Chris, watch what he's doing, okay? Because you're going to be doing the same thing. So on the next line, Ryan, say 105. Yeah, and say divide by 2. I say /2 equals. What is 105 /2? It's 52 and 52 with the remainder of 1. Yes? Is it 52 with the remainder of 1? Why is nobody answering?
Yes,
Yeah.
it is.
Yeah, it is.
All right, okay. All right. Okay, just in fact, even this takes more energy. Just say yes. Right? Yeah, okay. In fact, it'll be more fun if lots of people are talking and not just me all the time. Okay. So people should just be talking. Just be as vocal as possible. Thank you so much. Okay. Ryan, go ahead. Okay. In fact, be the computer scientist here and line up the numbers, line up the equal signs under each other. Well, you don't have to be like that, but it's kind of cool, isn't it? Gives you kind of practice for. Yeah, go ahead. Say, and you can say, yeah, remainder
Okay.
0. Yeah, go ahead.
Remainder is 0, and then 26 divided by 2 equals to 13. Remainder 0, and then 13 divided by 2 equals 6. Remainder 1, and 6 divided by 2 equals 3 remainder 0, and 3 divided by 2 equals to 1 remainder 1, and then there's 1 left.
Great. Yeah, you can go all the way. 1 divided by
And
2 equals 0, remainder
okay.
1. Yeah.
Yeah.
Technically, theoretically, you can keep going all the way. Again, really, isn't it, Ryan? Think about it. You can keep on dividing by 2 and adding lots and lots of zeros too. Yeah. 0 remainder
Mhm.
0, 0 remainder 0, 0 divided by 2 is 0 remainder 0. Yeah.
Yeah.
And think about it. Our number, our binary number, or in fact, this procedure that we just did is actually applicable to any conversion for any base to any base, whether you're doing base 8 or base 16. In fact, you can talk about this in the Reddit and say, hey, this is how I can use the same technique to convert from base 27, base 16, base 8, whatever it is. You can talk about that in the Reddit, or if not, we'll do more examples later on. Okay, so our number is essentially whatever Ryan has got there in reverse. Can you just all of you confirm that? Okay, that number 1101001 in reverse from bottom to top is exactly the number we started with. Yes or no?
Yes.
Yes.
Hey, you know what?
Yes.
Yeah, well, you know what? I'm supposed to get balloons or something like that. Well, I can't even see me, right? All right, okay. All right, okay. So that is our number. Now, so yeah, on the next line, just write this. Okay, just write this. Why does this work? Okay, on the next line, why does this work? Right? Why does this work?
Yep.
Yeah. All right. And then that's it. Okay, we're gonna toss this whole thing, right? We just wrote it there for additional hooks into our memory. So you can talk about these in the forums. Okay. Now, Chris, how about thank you, Ryan. Thank you for your explanations as you were typing these things. Chris, if you can do exactly the same thing, we're going to start a different number. Okay, a different number. In fact, what we're going to do is Ryan is going to call out a number. Okay, some binary number. It doesn't even have to be 7 digits, right? Just call some sufficient number of digits. So Ryan is going to call out a number, and then you can stop sharing, Ryan. Okay. How about
Okay.
from now on, I think 5 to 10 minutes, if max 5 minutes, I think. Yeah. Okay. 5 minutes.
Okay. So 0 1 0 1 1 0 0 1. Sorry if that was too fast. I
Can you
can't even
repeat, can you
remember what I
repeat that
said.
one more time?
I'll just make up a new number.
Hey, Chris, also
Okay.
increase the fonts. Yeah, can you increase the font size at all? Yeah, that's great. Yeah, thanks.
Okay.
Oh, it's because I have
0 1 1 0 1 0 1.
Was that it?
Yeah, I think so.
Okay. Okay, so the first thing we're gonna do is we have 1, 2, 3, 4, 5, 6, 7. Okay, 7 digits. So the same thing that Ryan did earlier, just multiply them all out to the power, starting from 0 to 6 because we have 7 digits. So when we do that, we get 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. 2 to the power of 4 is 16. 2 to the power of 5 is 32. And then 2 to the power of 6 is 64. Okay. And I have to do it from left to right. So 2 to the power of 0 is 1, and then multiply that by 1, and I'll get 1. 2 times the next digit from left to right would be 0. And that would be 0. And then 4 times 1, that'll be 4. And then 8 times 0 would be 0. Then 16 times 1, that would be 16. And 32 times 1 would be 32. And then 64 times 0 would be 0. Okay, and then the next step, we would just add them all up. So 1 plus 4 plus 16 plus 32 is that 53? Does that check out?
Yeah.
Yes.
Okay.
That, yeah. That's fantastic. Yeah, go the other direction too. Yeah, thanks.
Okay. And now 53 divided by 2, that would equal that 27 remainder of 1?
I think
Sorry?
26 remainder one.
26 remainder
Yeah,
of 1. Okay.
26. Right?
And then 26 divided by 2, that would equal 13. Remainder of 0. And then 13 divided by 2, that would be 6. Remainder of 1. And then 6 divided by 2 would equal 3. Remainder of 0. And 3 divided by 2 would be 1. Remainder of 1. And then 1 divided by 2. That would just be 1. No, that would be 0 with the remainder of 1. And then when you write it in reverse from bottom to top, now I'm looking at this. I think I messed up somewhere.
No, no, no,
No,
you
I
did
think
not
it's-
mess up.
Oh, no?
Yeah.
Oh,
Yeah, I think so. Yeah, who said that? Who said he didn't mess up?
It's me. It's Rina.
Rena, yeah, okay. You know what? I can't even see most of you. I can see like 4 or 5. Yeah, I don't know, eight people. And I can see myself. I got to figure out these Zoom settings. Yeah, okay. But Chris, you should go ahead with your explanation or trying to figure out with other people, or maybe Rena can help too. What you had, you should double check it like you were doing. Yeah. Make sure that it is you got what you started with.
okay. I think I would just have to do the dividing one more time, right? And then that would give me the 0 I'm looking for right here. And
Yeah,
then it should
basically.
match the top. Yeah.
Mhm.
Okay.
I think the zero at the front is just a zero because every number has an infinite amount of zeros before it. And it just so happens that the number you got shows the zero before it.
So that is fantastic. What Josh just said actually just completes what I was going to say. You can add any number of zeros in front of a number. It doesn't change the value. Yes? But you can't add zeros on the end, on the other side. But you can add on this side, you can add any number of zeros. It doesn't change. And I think that is what Josh was saying. So you did have that number, but you added a leading zero there in your binary. That's why you didn't get the exact thing. But that's great. Thank you so much, Chris. Now, who would like to go after Chris? I think Caitlin, you were quite comfortable. Yes.
Yeah, I'm pretty.
Yeah. Jacob, do you want to go, or do you want to pass this time? Maybe Rui is next after you.
I mean, I can go, but if you don't want me to, I can pass. It's
No,
your
no,
call.
I want you to, right? Only if you think that is, it's too simple, you can say, I can work it on my own too. That's up to you. Do you want to go? It's
Why
gonna be
not?
2 minutes, right?
Yeah, I'll
Somebody
go,
say,
sure.
who is this? Caitlin this time. We'll call, no, not Chris. Chris will call out a number.
All right, should I share my
then,
screen here?
7, yeah, share your screen just like that, increase the font size. And now you can hopefully do it faster even. And so 7 digits, and you don't even have to follow the same format that Ryan did, right? So I think Josh followed the same format. You can try to do it in a different format. You can say, I'm going to do it in a different way, different structure, all kinds of interesting things could emerge. Because each person would have their own, flavor to this. And one of this might actually click and say, hey, that's really cool. Or you can come up with a blended approach too, which actually might help in your exam. In your data representation quiz, you have a bunch of questions like this with, what is the number and so on, data conversions and things like that. Now, here is where generally in math and computer science, practice helps, because in your exam, maybe you can solve the problem. Maybe you can solve the problem in a half hour or a 1 hour, right? By thinking about it and doing these things. But just by doing it repeatedly, you just get in the hang of it. And say, someone wakes you up in the midnight and say, give you a problem, you can solve it like that. You just keep doing this like this. Now 5 minutes, we're going for 5 minutes before your data representation quiz. Aim to get things like this, not just this, floating point arithmetic, signed magnitude notation, converting from 2's complement and back and forth, right? All of that, try and work through practice problems. If you're stuck for practice problems, ask me. You just go to Google, any of these chat, the machines, and say practice problems for data, 2's complement data conversion. You get a ton of those. And some of these you can even just do online. But it's important to say, I've done enough so I understand how this works. Okay, that means out of 20 questions, you'll be able to get 17 and you'll run out of time. Does that make sense?
Yeah, it does.
After a certain point, it is not enough to just understand something, right? You got to get to the bottom of it and you just get practice. And you got to do this for the data representation quiz. So before the quiz, before you start programming, because I can guarantee as soon as you start programming, people are not going to start thinking, they're going to stop thinking about data representation like this. This is the only week you get to really dive into it and put programming on a shelf. Don't think about programming this week at all, right? Except for, doing the blue quest number 1. Okay, that should take you like 5 minutes. But other than that, data representation, because from next week onwards, you're not going to do this, but this will help. This will greatly help. If you're solid on this, that'll come through in the next. All right. So increase the font size. Hey, Jacob or Jake?
I actually go by Nadal. Jacob's my first name,
Oh,
but I don't go
Nadal?
by it.
Nadal.
Nadal.
I think you should be able to change. You should be able to change.
Yeah, I just didn't want there to be confusion on the Canvas end because Canvas has me as Jacob and not
I
Nadal.
see.
So yeah.
Yeah, okay. You're gonna get used to people mixing it up and calling you Jacob from time to time. Right. So you're gonna increase the font size.
I mean, I did Control Plus. I don't think it's doing much.
Yeah, it's
though.
not working. This is a
No.
Windows machine. This is a
Yeah,
Windows machine,
it's Windows. Yeah.
and this is Notepad, is it?
Yeah.
Do you have a
Oh,
Windows
what I
key?
did
Windows
was
Plus, maybe? Try
I
Windows Plus.
I hovered over view and it said zoom in, I think.
Oh, you're right.
Yeah.
Oh, maybe it is, but it is increasing. You just don't see
Yeah,
it. You don't have any characters.
yeah, that's better now. That
Yeah,
should be enough.
Punch a bunch of characters and then zoom out. Zoom in. Now you
Yeah.
can zoom in more.
Okay.
Yeah, all right. No, that's okay, I think. I just need to increase. Because as it is, my 15-inch screen, and then I'm only using half of it for the screen, and the rest of it is your photos. And I'm not getting all of you on screen anyway. Right. All right, so who is gonna, Chris, you're gonna call out a long number? Like, make it like 9 or 10 digits binary. You can just keep tossing a coin and say heads 1010, something like that. And then Jacob is gonna do
Okay.
it. Now, those of you who don't get a chance to do it today in here, you're going to do exactly the same thing. Take a notebook after class, maybe. And you're just going to come up, ask your brother, sister, mom, dad, someone to call out a number, right? You're just using 1 and 0, like 10 digits or whatever it is. Convert it back and forth so that you know that you got the thing right. Because that is your check. Yes, in math, you do the check, right? You get the solution set, and then you plug it in to see if you actually got the equations right. Like that. So you do that, and then do the back conversion and make sure you get the exact same thing. Everybody has to do that. Now, if it takes you 10 minutes to convert, I don't know, a 10-digit binary number, 10-digit, right? 10-digit binary number. If it takes you 10 minutes to convert that, do a few more, like 4 or 5 more. By the time you're doing the 5th or 6th one, it'll probably take you 10 seconds, 10 or 15 seconds at most, right? You'll be surprised, totally surprised. Why? You know what? I thought 10 minutes and I understood it, but now I can do it for 10 seconds in 10 seconds. Okay, that's, you still understand it, but it's a difference, a whole order of magnitude difference. So so you got to do that repeatedly until the end of this week. This and all of the other problems. I've given a lot of problems in module 0, right? In module 0, when you read through it, I have some bubbles or I have footnotes at the bottom. I say, why is it this way? Why is it this way? Right? And so on and so forth. Those are not just, interesting trivia things for you to spice up the module. No, those are things that you can actually latch on and ponder, because by pondering that, you'll get a better understanding of the topic we're talking about. And you don't have to ponder on you by a lonesome self. You just take that and say, hey, in module 0, it says this, and I was trying to think about it. Well, what do you guys think? The fantastic conversation started on Reddit. Okay. And you can say, here's my reason. I didn't look up any past sources, just pure, pulled it out of my head. And so it could be wrong. Fantastic. Okay. Even better than saying, well, you know what, here's my paraphrase of something I found on Wikipedia, according to, Euler in the 17th century, paraphrased by some other mathematician. And here's my understanding of that. What kind of nonsense is that? Right. So you can just cut to the chase and say, well, you know what, here it is. And this is my understanding. Maybe it's wrong, but someone can tell me why it's wrong. Okay. That is worth 1,000,000 times more than trying to understand something and saying, this is my understanding of that. Yeah. So even if you're wrong, that's okay. Because in 10 years' time, when you come back and look at these videos, well, unfortunately, they're not going to be public, right? But I don't know, we'll figure out some way. We'll figure out some way in which at least the class participants will have access to these links for eternity, right? You can come back to this. They'll be worth a lot more in your eyes than Instagrams and Facebooks and other things you share on social media, right? But this is because this is a true picture of you, and you'll be interested to say, hey, well, wow, that's incredible. I was trying to look how into that I was, right? Trying to figure it out bit by bit, one bit at a time. And it's really cool. It is really valuable because I think I know that a lot of students have come back and told me that it's actually very interesting for them to look back on their own histories in Reddit to see that. Well, that's interesting that I said that. So you and those moments are more valuable to you, I think. So go ahead, okay? So we'll figure out some way to make these videos available to you in future. Go ahead. Sorry, I'm sorry. I meant to say sorry. Go ahead.
Okay. 1 1 1 0 1 0 1 1 0.
All right. Am I on the right track here? Just to make sure.
Two to the third is 8, not 16.
Oh my God.
Mm-hmm.
Uh, to the seventh is 128, right? Just to make sure. Could someone confirm that?
Yeah,
Yes.
that is correct.
Okay, this should be 256.
Yep.
I don't know.
512, I think.
512.
Mm-hmm.
Alright. And now I'll just be multiplying from right to left. So it'd be 1 times 0, which is 0. And then it's gonna be 2 times 1 is 2. 4 times 1 is 4. 8 times 0 is 0. 16 times 1 is 16. 32 times 0 is 0. 64 times 1 is 1. Wait,
Yeah, 64 times 1 is 64.
yeah, I'm just finding out which one I'm lost on here, because that's a 0. 1. Oh, so I have 2 more ones, right? I don't know why I wrote all of these down then. Okay. Yeah, I don't know why I wrote 2 to the 9th. That's unnecessary. So this pretty much looks like it's it. So it's 1 1 1 0 1 0 1 1 0. Yeah, it checks out. So it's right. So I should do it in reverse. Wait, no. What? Sorry, what am I doing? I need to add all of them up. Yeah, I got it. Give me a second on that. Did you guys get 470?
Yes, that is correct.
Okay. So now it'd be dividing 470 by 2 and so on and so forth to go back to do the reverse operation. So 470 divided by 2 is equal to 235 with the remainder of 0. And then 235 divided by 2 would just be 117, remainder of 1. Is that correct?
Yeah.
117 divided by 2. Goes 58, remainder of 1. We'll just align it here, so looks okay. And 58 divided by 2. That's equal to 29 with the remainder of 0. And 29 divided by 2 is equal to 14 with a remainder of 1. And then 14 divided by 2 is equal to 7 with a remainder of 0. 7 divided by 2 is equal to 3 with a remainder of 1. 3 divided by 2 is equal to 1 with a remainder of 1. And then 1 divided by 2 is equal to 0. Wait. Did I do something wrong here? I don't know if I,
No, you're okay. 3 divided by 2 is 1, and then another 1 is left. So it's gonna be the final one.
oh, okay. Because I thought I was doing something wrong, because when other people were doing this part, you were doing 1 divided by 2 is equal to 0, and then you had a remainder of 0 as well. I don't know if I'm tripping. I don't know if I'm. I don't know
No,
why I'm
go
making
ahead,
this.
like you were saying. Was it Rena? Let's see, yeah, someone. I can't see all of you again. But yeah, just keep going ahead. I think that's great.
That'd be 0, right? And then I'd do. But that's not right. So it just have to be 1 though, right?
Yeah, that's correct.
Okay. And that's 111010110. And that checks out. So it seems to align with our initial.
Fantastic, fantastic.
Yeah.
Right. So yeah, so you see how you thought you understood it because we saw it before, but still when you work through it, you get stuck, right? And
Yeah.
and that is the
So
reason-
it was because it was not like 7. It was like 9 digits. So it's a lot more
yeah,
to deal
yeah,
with.
yeah. Slightly different cases.
And like
That's why it
I
helps
could do
to
this in my head, but like I don't trust myself, so I have to like check. Like 470 divided by 2 is 235. Like I don't know why, but I just don't trust myself with basic arithmetic
No,
sometimes.
it's just practice. It's, you just have
Yeah.
to keep doing this, especially also you're doing it on screen in front of so many people and you're having to talk through it at the same time. So there's multiple loads on your brain at the same time. Yeah.
Mm-hmm. Yeah.
So yeah. So but at the same time, I think it's advantageous. It's advantageous to practice repeatedly. Well, the second best thing is to practice on your own. Right now, we're running out of time, so the rest of you will have to do the same thing. Pair up with your mom, dad, brother, sister, friend, whoever it is. Ask them, or go to the STEM center. Ask them for numbers, and over dinner, maybe when you're eating, after you eat, maybe solve a few. Everybody's got to do this and time it on your watch and try to get this done in 2 minutes or less, the whole thing repeatedly. If it takes you 3 minutes, do a few more. It'll get faster every single time, I can guarantee. And besides, you'll also refine your notation. Maybe you won't write 2 times 0. Maybe you'll omit writing that entire column. You'll just say, that's my number, time, bam, 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 is another sequence of numbers right here. So your notation changes, all of these things, and you can share these tips on the forum too, and say, this is the way to do it, right? So I'm saying that as far as converting from binary to decimal and decimal to binary, this is a useful set of exercises you can try on your own, and getting warmed up for today. Now, what you need to do for until Thursday is try and do the rest of the exercises in the module. If you have any questions about these things, best thing to do is ask in the forums, right? Maybe what is after binary conversion? Maybe octal and hexadecimal, right? So maybe you're going to look at this and say, hey, here's that number. What is that number? How many digits are there in this number, by the way, Jacob?
I think there's 9.
9? Okay, 9. How do you convert a 9-digit binary number into hexadecimal? Can someone tell me, hey, Caitlin, you got your hand raised. Well, you have a question?
Oh,
Caitlin?
no, I just wanted to add something, if that's okay.
Hey, go ahead, add it.
I noticed that Nadal and everyone before, they typed remainder a lot. So I just wanted to say that in module 0, there is a really good video link that you provided, and it basically said instead of just typing out the remainder 0101, you can just leave that out and look at the numbers. So like the numbers after you divide it by 2, which would be like 235, 117. And if the number is odd, then you just write 1. If it's even, then you write 0. And it's not a big difference, but it saves you from the remainder, the long.
Yeah, and from running all of it down, so you
Yeah.
can do it a lot quicker. Thank you for that.
Thanks, Caitlin. Yeah. So these conversions, hexadecimal. How do you convert this 9-digit binary number into hexadecimal? Can someone tell me? We're not going to do this, but it's very easy. Hexadecimal is we realized that the binary bit pattern, we can break it up in chunks of 4. Okay, so if you have a series of bits, break it up into chunks of 4, and the reason we break it up into chunks of 4 is that if you take 4 bits, how many bit patterns can you make from 4 bits? So each bit can be 0 or 1, okay? So, and you have 4 of those bits next to each other. How many different combinations of ones and zeros can you have? So each one can be in 2 possible states, yeah? 0 or 1.
So it's 2 to the
So
4.
this one, sorry, yeah, go ahead, Kate, Rena.
Is it 2 to the 4? All the
2
possible
to the 4,
combinations?
thank you. Yes, 2 to the 4, right? So, and why is it 2 to the 4? It's 4 bits. For the first bit is 2 possible states. The second bit is 2 possible states for each of the 2 possible states of the first bit. So it's 2 times 2, right? The third bit is 2 possible states for each of the 4 possible states of the first 2 bits. So it's double of that. So the number of bits is basically 2 to the power of the number of bits. So with 4 bits, you can have 16 patterns. Yeah. So what we did was, well, you know what, instead of writing these long bit sequences, yeah, and it's really hard for humans to figure out, you know, as it is, I couldn't tell how many digits there are in this binary number. But a hexadecimal is slightly easier, not so much easier, but slightly easier because it chops up, you know, bits into 4 chunks of 4. And for each of those chunks of 4, it gives a name. Okay, that's all it is. So each chunk of 4 bits is a number from 0 to 15 because there's 16 possible bit patterns. And you have to convince yourself 0, 0, 0, 0 is binary 0. 0, 0, 0, 1 is binary 1. It's a value 1, right? Because 2 to the 0 is 1 and that's 1, right? So 0, 0, 1, 0 is 2 and so on. So 1, 1, 1, 1 is 15 because 8 plus 4 plus 2 plus 1, that's 15, isn't it? So you have 15 possible bit patterns in 4 bits. But we have only 10 digits, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 10 shapes that you can use. But we have 15 shapes, 15 bit patterns. We need a shape for each one of those. And so hexadecimal was born and said, you know, we'll use the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 for the first 9 bit patterns. For the last 6 bit patterns, we'll use the letters of the English alphabet, A, B, C, D, E, F. So instead of, you know, for each of those bit patterns, instead of having, you know, those cumbersome binary numbers, we're going to say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. For the bit patterns, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 2, and so on, all the way up to 1, 1, 1, 1. Okay, so we have 16 bit patterns. We're just giving a name to each bit pattern, A, B, C, D, E, F, or 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's all, okay? And we're going to translate these long strings of bits into their corresponding bit pattern. So sometimes when you go to email or, you know, you do a generate hexadecimal, you know, or when you get email or look at log files, you see these long hexadecimal numbers. Yeah, that's what they are. They're basically hexadecimal versions of the bits that are actually inside of this computer. In my computer, I have transistors and, you know, individual bits. The bits are actually electronic circuits, right? There's transistors that code ones and zeros, there's switches. So if I want to look at a certain part of my memory, which is actually just switches, current flowing, current not flowing, current flowing, current not flowing, 1, 0, 1, 1, like that, right? So if I want to look at my memory and say, what is stored in that memory? So then, you know, the AI in my computer might say, well, yeah, I've looked in that memory, and in that memory, I see current flowing, current not flowing, current flowing, not flowing, all of that in 1 nanometer or something like that, right? So all scrunched up in there, and it sees that. But if it tells you that, it's going to be, you're going to have a hard time deciphering that. Okay, so when you say, oh, dump the portions of your memory, that's what it's going to show you. It'll show you, well, in my memory, I have A, F, 2, C, 1, 0, 4, right? You'll see these memory addresses, and you know these hexadecimal numbers that you see are essentially just, you know, translations of the underlying bit patterns. That's all that's going on. Okay, so you can take it upon yourself to try and convert from binary to decimal. But we've done in class exactly the same methodology. Convert from binary to hexadecimal. You can also convert from decimal to hexadecimal using the same technique that Chris and Ryan, all these people, Jacob, right? They all did the same. That's the same technique. Work it out. Okay, exactly the same. Divide, remainder, and so on. Exactly the same thing for converting from decimal to hexadecimal, which is 16 bits, right? So, you know, I mean, it's base 16 symbols. So you're gonna try and figure out. So here's a puzzle for you, right? So something that you can think about and talk in the forums and say, hey, we did the binary to decimal challenge, but without looking at how it's done, I try to adapt it to do from, decimal to hexadecimal, right? If you're feeling particularly challenged, right? Not really necessarily at this stage, but you'll probably get to do it in, a few weeks from time now when you're doing programming, is to basically do a general purpose thing, right? Here is a procedure I have that you can give it any number in any base. It'll convert it into any other number in any other base. And it is exactly the same as what Ryan and Jacob and all these people did today. Exactly the same, right? Just the icing on it. It's just been rearranged, different symbols here and there, right? Some minor subtleties handled here and there, right? Just to account for the different base changes. And it's the same algorithm. So the algorithm is the same. Try and figure it out. It's actually a worthwhile exercise. It's not in the modules. But if you try and figure it out, share it in the forums. And it's a great post for you to come back and look at too, right? Because you are shown an algorithm on one thing, and then you are asked, try and figure it out, and now work it out on hexadecimal. It's like saying ChatGPT, yeah? This is enormous amounts of work goes into today trying to figure out if ChatGPT's behavior or any large language model's behavior is emergent, or it's actually there in the training data. Because if you have training data that is now spanning trillions and trillions of parameters, it becomes really hard for us to check if certain sequences are there in the training data, right? Oh, and so you just say, this is the answer. And then the New York Times could come back and say, hey, that was verbatim in our newspaper in 1845 or something like that. And it got into the data. This is really hard. Or even in math, you can say, you give it a lot of proofs and say, now, can you tell me if this theorem is true based on all the lemmas that I've given you, or something like that, right? And is it able to reason and infer and try to figure it out? Or has it actually matched the question to some question asked by some graduate student in some university and some answer given to by a professor in their blog? Yeah. It's all possible, isn't it? When you're dealing with data of that scale. So a lot of research, if you're interested in AI, goes into figuring out questions that can be provably shown to embody emergent reasoning, emergent rationality, which is not fed in. But the system has, it comes in, and we're trying to, now our task becomes, all right, this is emergent, but we don't know where it came from. We're going to try and figure it out. Right? Where did it come from? So that's another research problem. But trying to come up with these problems itself is a great field of research now. It didn't used to exist like 10 years ago. Now it's a new emerging field of research. Again, people can get romanticized into these notions and say, oh, I'm going to do this, I'm going to do this, I'm going to learn about these things. But the bottom of all of that is just straight, clear thinking. Okay, doesn't matter. You don't have to specialize in one particular field to say I'm going to be great at AI or machine learning and things like that. All of that is just straight thinking applied, whether it's in physics or math or in computer science. It's just one way of thinking, and different subjects, different things that we learn are just different ways of exposing you to problems that will let you distill out that central message, which is the same in all of the languages. So learning C++ is not with a view to a utilitarian view of saying, I want to know how to build things. No, from now on, from today, maybe, or maybe the recent past, right? Learning anything is with a view to looking at examples in the world to train our own selves, to figure things out on our own. Because things are going to be getting done for us very soon. Doesn't mean we're going to sit around and, figuring things out actually has pleasure associated with it, and you got to figure it out. Because otherwise, what are you going to do when everything else is taken care of for you, right? So that is what, you have to get to the bottom of this, and practice will get you there. And that is why in a community college course or whatever it is important to apply yourself fully and not overload yourself with tons and tons of units, right? CS2A, maybe not so much, maybe in this quarter. Fall quarter, notorious students take on unthinkable number of units, and as a consequence, none of these classes get their due time, right? In CS2A, 2B, 2C students, I see 2C students, right? It requires a lot of time and energy to get to the bottom of things and truly understand things. They're being pressed for time, enormous amount of stress. So don't do that. You have a lot of time, especially with all these advances. You're going to have a lot of time on your hands to deal with, to learn anything you want later on. You don't even have to go to work. The governments will pay you to just sit back and learn and be productive, or not be productive, just be learn off the streets, have a good time, but enjoy yourself, right? And that's all going to happen. And so why hurry through things saying I'm going to do 50 units this quarter? take it. This is an enjoyable course. Okay, there are lots of enjoyable courses like this at Foothill. Any university you go to. Not all courses are enjoyable because, maybe the subject matter is enjoyable, but the professor might be a highly research-oriented person, right? So deeply into their research problem at that time in their life, maybe, that they don't have time for anything else, right? And students are, at this time, I just have to get through this lecture and then go back to my research problem. So maybe there are courses like that. And, I've taught courses like that too in the past, but there are courses like that, professors like that. So you got to figure out and say, I'm not going to go to the classes in any school or university that I go to that has easy things and easy A's and things like that. If you go to Foothill Reddit and say, go and search, rate my professor, whatever it is, everybody is looking for, this is an easy A, easy A, easy A. What is it? This is totally useless. You pay money to get an easy A and it's 150 bucks. That's total nonsense, right? So you pay 150 bucks, you want to get your 150 bucks worth, which is really knowledge. That is what is valuable to you. And so go ahead and spend all the time you have at your disposal trying to get to the bottom of these things, and use this time in the first week to figure out what is going to benefit you, right? Really, to get to the bottom of these things, and focus on those courses. And that's why in the syllabus too, I highly recommended that if you have to make up your units, go and enroll in some of these other really cool courses, right? There's so many cool courses in all of these community colleges. Ceramics, we have some kick-ass studios and facilities, everything, acting or improv, music. But the thing is, if you are doing STEM and doing those classes, really cool, because STEM takes a lot of time and energy. It takes a lot of mental concentration and focus. That also takes a lot of mental concentration and focus, but the aim of your life in the next 10 years is not to become a great magician or a great musician, right? You can say music and acting and improv and all of those are interesting, fun things to do on the side while I'm, facing these frustrating and stressful problems in my STEM subjects in computer science and math. And these other things will just give me a little bit of time to relax. So while I'm throwing clay on the wheel, I'm thinking about, why is my matrix not multiplying properly? Okay, so that happens really because you need to be doing something else and also be mindful of something else. And those things will give you an opportunity to do this because you're not trying to do A's there. That's the importance, right? That's the difference. Because you're doing those classes, other classes as digressions, your mind is already made up. Your your expectations of that class are different when you enter those classes, right? When you enter a ceramics class, you're not going to enter it saying, I'm going to get, so good here that my next piece is going to be at the Smithsonian. That's not your aim when you do a ceramics class. You're doing it, it's fun, right? It's fun. It's a little, I can break away from STEM and do this for a little bit so I can come back to it recharged in STEM. So that way but whereas if you do all STEM classes, you want to do A's in all of those, like 5 A's, 5 STEM classes. That's totally useless, right? So make up your your credits by enrolling in all these, and it also gives you an opportunity to explore in a campus like a big university or a college. There's so much more to offer than just that narrow slice that you get into. And here's an opportunity for you to say, all right, here's what I'm specializing in, but this is my opportunity to get to know other people in class, right? Other people in the college. Because the people who do the art classes, they're very different also sometimes in their mentality, how they deal with the world, their outlook is also different in many ways. So you get to experience life from many different perspectives, rather than just lock yourself into one particular field. And in your college, that's what I said, you have the luxury of making a lot of mistakes in college because people expect you to make mistakes because mistakes are an integral part of learning. So so since you're expected to make mistakes, go ahead, make as many as you can, as much as you can for all the money you paid, and make the most of it. Okay, so for next class on Thursday, I'm hoping that all of you will come having practiced in with the material in module 0. If you find anything confusing, ask in the forums. We'll jump in and help. And we also have a tutor, by the way, Isidore. Where is he? Maybe he didn't make it today. I'll let him know, right? So he will also start attending our classes. Now we have a tutor. He was our 2A student last class. He was one of our top students. And by the way, one of you was a top student. I will nominate you as a tutor for next quarter. So actually the pay is pretty good, you know, especially with minimum wage laws in California and so on. You get to charge 19 hours per week for, you know, a pretty easy work, especially since if you do CS2A, do a pretty good job at it, and just do everything. I think it's even online, you know, you can just do online tutoring at the STEM Center, 19 hours. There's a bunch of tutoring options. There's a lot of opportunities at Foothill, right? When for the right. So explore these things. I'll be able to help you with these things too, right? I have, you know, I know many people here who may be interested in these things. So I'll link you up too. So explore all these classes, do all these fantastic things. Have a great time. Have a great time. And the trick is for you. Your trick. You have to figure out how to enjoy life and have a great time while also at the same time making strides in what you want to do in life. Very often, as was the case in the first few years when I went to college, right? When I was a kid, like you guys, when I went to college, first couple of years, I didn't have a clue, right? I spent a lot of time just partying and hanging out. I didn't have a direction in life. I just wasted a lot of time. And then after that, I realized, oh my gosh, I lost 2 years, or you know, many years really. I could have done a great deal of more things if I had realized sooner that, you know, this is all a waste, because all of these things, I had a great time, I had a great time, I had a great time. But you know, all of that tends to lose value as you get older and older, because you tend to forget, you know, yeah, I had a great time. So many people have had a great time, right? But what is it that sticks with you? And then that starts to matter more. And then you realize, well, you know what? Well, I could have had a great time in many different ways, but I just chose the wrong ways to have great times. Yeah. So that is the challenge for young people like you. You got to figure it out. You got to figure out, how can I have a great time, but at the same time also be safe and also learn in such a way that I can be, you know, kicking ass and having great time later on down the road. Because later on, I can tell you, right, a few years now, you know, if not already or soon enough, right, on universal basic income or something like that, because everything is going to be like super duper easy to make, you know, everything will be easy, right? If learning is just going to be, yeah, I don't know where I was going with that train of thought, but you know, it is going to make a huge difference. And yeah, being competent. For the few years you have left, where you may actually end up working for other human beings, knowing your shit is really super duper important, because it's only if you know what you're doing, right? If you're good at what you're doing, you don't have to, but you can stand up to mediocre people who happen to be in a position of authority saying you have to do the wrong thing, right? If someone above you who doesn't know their shit says, you know, you got to do this, and you know it's wrong, I can prove it mathematically it's wrong, you can say, no, that's not right. You know, if you do it this way, you get an improvement. And they'll say, yeah, great, let's do it that way. But if you didn't know it, if you didn't know something, then you're beholden to what other people tell you, right? So you can be yourself, right? That is why being yourself is so valuable, because it's so hard. You can't be yourself until you actually know your shit. Okay. And so people always say, be yourself, that's a ticket to freedom, right? But being yourself is not something that comes free. You got to earn it. And you earn it, unless you're actually completely set already, is by saying, I know how to do this. Nobody has to tell me. I don't have to validate myself to anyone. Right? And you and I, everybody can get there, right? I don't believe in all that nonsense that says only some people are born with this gift to learn these things and they get these things. No, everything is just perseverance. You stick at it long enough, you will get it, okay? Whatever it is, whether it's acting or music or whatever, you stick at it long enough. Just that some people have been in certain positions where they don't, you know, they've done it long enough, but they just don't realize it, okay? Because it just comes, you know, interesting. It's interesting. They find it interesting, or they found things in it that is interesting, right? So find things in computer science. If you want to major in computer science or mathematics, which, you know, those are things that I would recommend for the future, okay? Because physics, chemistry, all of those things, everything, many of these things will just sooner. The more empirical something is, the sooner it'll become irrelevant, okay? I think, right? Because at the rate at which things are happening, many of these things will get automated. Which means that also, because it's more empirical, there's more softness, and it'll take you longer to converge to the truth, as it were, okay? Whereas with mathematical sciences, you get clearly labeled positive and negative examples every time, which means you can converge to the truth much faster. Without external, right? Because, you know, with empirical sciences, even if you do something, you need external validation to know whether it's true or not, because you're beholden to the empirical world. With math and logic and computer science, you don't need anyone at all, because just logic can figure it out in your head. So that is why I think in the future, where it's not important what you know to make your life better, because everybody's life is going to be better anyway, right? It's only going to be important how to derive value out of life, which is, getting to the bottom of things and understanding things, and that's where the meaning is hidden, right? That kind of thing requires some kind of thinking. And to get to that kind of thinking, that is finding your sense, finding your own self, right? Finding that thing inside of you that everybody has, but very few people seem to realize that and just frittering it away. So, but you got to find it, because once you find it, you're set. So, but in order to do that, you need to develop that mode of thinking, and that kind of critical thinking comes through these things much faster than if you were to do something else. Okay, that is my 2 cents. Hey, again, on Thursday I might completely change my mind. All right, because I've been riffing about completely different things, but that's what comes to mind today, because this is the first time we're seeing each other, first class of the quarter and all. And you're going to be dropping classes, okay? This week you're going to be dropping classes. I don't want CS2A to be one of those, okay? So make sure that your schedule is nice and plump with interesting things to do as well as challenging things, okay? If you're all challenging, people always overestimate their abilities, okay? Especially at your age. You think, all right, I'm born to change the world. I got to do a lot of things, right? Found 5 companies by the time I entered college. Yeah, okay. You got a lot of time to do all those things, with genetic engineering. You're really about 200 years or something like that. So you're going to say to yourself, I'm just going to make sure that I have a good time and learn a lot, okay? That is what you're here for. So, and again, not here, any other college you go to, you're bound to find good classes, bad classes, professors who have, their life situations allow them to teach good now. Whatever it is, you got to find these things, and that's all up to you guys, right? You can't go to a counselor and say, well, what should I do? So you got to do some homework on your own. Just like you're going out there looking for a job, right? You're not gonna, join any place. You're gonna do some homework first and find out, are they doing any interesting work, right? Are there interesting problems, challenging problems if I join them, right? Or else I'm just gonna give some. When I join them, they give me a ton of data, terabytes of data, and say, all right, go ahead and clean it up, okay? Believe it or not, a lot of machine learning engineers do that. I know, right? So, I used to do that a very, very long time ago, just from my experiments. In speech engineering, you got a lot of data that you got to sift through. But even language modeling these days also there's a lot of data, but that's the major part of machine learning and AI, right? Just learning to deal with data. If you know how to deal with data, you're 99% of the way to machine learning. I can tell you that, okay? 99% of the work in machine learning and AI is in the data. So if you know how to grok the data properly, and if you know where the patterns are and what you should be looking for, that intuition, you got to inject that intuition to pull out more intuition, right? Like big fish for small fish or whatever it is. So you inject the intuition into the data, you can see the patterns. And I have firsthand experience of these things, right? So when I was a junior engineer a very long time ago, I used to look at mountains of data, and I was so confident, right? I was willing to put $1 million. At that time, I didn't have $1 million and all. There's some senior engineers there. I said, there's no way there's anything in there. We should trash it right now and save like a ton of disk space, okay? And he just sat next to me for a little while, and he was, up and down, scroll up and down. And he said, no, actually do this transformation and you'll see that pattern emerge, right? And I did that, and I was there. The signal was there in the data as clear as day, and I couldn't see it. And it just comes with practice. And it's not just expertise or something like that. That's what I say, right? It's not senior, and it's just, if you go to an X-ray technician, right? And at a hospital, they'll show you like 5 million X-rays of people's lungs and say, well, those guys have got problems. These guys don't. And you can't tell for the life of you what's going on there. How does that happen? It's just training. It's just training, like neural nets. Train lots and lots, one after another. They actually just get, even minor deviations they can spot. Yeah. And that is how things happen with data too. Right now, you may think that all of the data, there's nothing in there, I could just toss it. But you just play with it long enough. And lots of people give up. Don't give up. Don't give up and say there's nothing in it. There's lots of things in it, just like in CS2A in computer science. There's lots in it. Don't give up and say, no, there's something in it. I'm going after it. You will find it. And with data mostly. All right, so data representation is really, really key. Lots of, other classes skip it, but don't, I'm glad we don't. But please do have extended discussions. Convert all of your names. Everybody's name. We didn't have a chance to do it in class. Everybody's name, convert that from your base 27 representation. Like, except Rui will probably do the whole name, Rui Dong, right? This is because only you got 3 letters in there, right? Okay, so you got to make sure that you go to 27 to the 0 plus 27 to the 1, maybe up to 27 to the 6 at least, right? Make sure you got a decent name there, convert it, and then from that number, go to hexadecimal By dividing by 16, take the remainder. Divide by 16, take the remainder. Okay, that goes to your hexadecimal. You can say in hexadecimal, that's what it is. And hey, I got a pronounceable hexadecimal name, right? You get a super extra credit for that. Okay, so nobody, two people have had pronounceable extra credit, hexadecimal names. Like Abe was one of them. Okay, so one person had an extra came up with a hexadecimal name of Abe, ABE. It was a hexadecimal number, and it was pronounceable. And so they said, "Oh, this is my name in English, and this is my name in hexadecimal. I'm Abe in hexadecimal." So maybe you got a yeah name that is pronounceable too, like Bubba or something like that. Thank you all for your time. Did we get, was it useful today's class? Well, from next class onwards, we'll try and make it more formal, more interesting. But today, I just wanted to get the basic stuff across. The general idea of what you should be trying to do. Essentially, this week, don't worry about programming. Just nail down all the data representation. That's what I wanted to say. But we did a couple of problems, but hopefully raise your hand if you think that was enough for you to now go into the data in the module and then work out all of the data representation problems, or not all of them, maybe up to even floating point representation, right? Maybe even signed and unsigned. Because when you get to signed and unsigned, you can talk about that in the forums and say, hey, I was reading about this and I didn't understand. Can someone explain? That's fine too, right? But you should be in a position by Friday to complete the data representation quiz and just be done with it, right? From next week on, we will not be doing data representation explicitly like this. Is that okay with you guys? I know it's past time, and thank you all so much for sticking around and humoring me, blabbering away, at length. Thank you all. I'll try and keep this short, okay? Because I think in feedback also, people have said that sometimes I just tend to go off on tangents. I just need to keep an eye on it, okay? So I'll keep a more careful eye on it from next class on. Once we start coding, I think it'll be easier because we'll have a lot more to cover. Today I was just. Thank you all, okay? And I will see you on Thursday. Are you guys coming back? Raise your hand if you're coming back on Thursday. Right? You're not dropping. Okay, great. All right, I'll see you on Thursday. And thank you all so much for your time. And do all the things in the module and discuss them in the forums. Okay, I look forward to seeing them. Bye.
Thank you, Professor Venkatraman. Bye.
Bye, Professor.
See ya.
Thank you, Professor.
Bye. Bye.
I just had a couple
Hey, Alan,
questions.
you got a question?
Yeah.
Yeah,
So
yeah, sure.
or I guess so I'm completely new to coding. Like
Yeah.
and so I guess yesterday when I was doing the Hello World assignment, it just kind of felt like I was copying off of websites that I would look up like, okay, how do I do this? How do I do that? But so I just wanted to make sure, like, if I just like look up like, oh, how do you print text on like C++ and like I start to like read a website, like that's what you kind of want us to do, or
Yes,
is that,
yes,
yeah?
exactly. That's basically, you should be looking up a lot of the stuff.
Okay. Yeah, because
not just
I did.
quest solutions. Yeah.
Yeah,
We do
'cause,
that
like,
all the time. When you start coding, for example, next week when you start coding on screen, like you share your screen and start coding, we won't know how to do these things. Sometimes we want to use a string and we want to extract the fifth character.
Yeah.
And I won't know how to do this because many of these things I look up, and then we're going to look up together. When you share your screen, we'll just open a tab and go to Google and do these things. So you can do this for yourself.
Yeah, because like I was thinking about it, because like I was thinking about it in like a perspective like maths and sciences instead of like something like language, because I did take language classes. Like you can't really like just make up words and like hope it's Spanish. You have to like kind of look it up on like a dictionary or a teacher tells you.
Yeah.
And so that's like my mentality. I was like, okay, maybe I am supposed to do it like this. But yeah.
No, this is fine. You can look up because you're not looking at the solution. You're just saying,
exactly,
how do I do this in Python? How do I do this in C++ and things like that? You're going to be doing this all along for the rest of your life.
I appreciate that. Yeah. And thank you for the email, like, and not just like I
know. It's more fun that way too.
Yeah, exactly. Because like I was there struggling and I was like, oh my gosh. And then like, I got desperate and I emailed you, but then like after you didn't respond for a while. And so I was like, you know what, like, I think it might be this. And like, I reread like the website and then like, it made sense and it clicked. And I felt better about like, oh, okay, I just did it by myself, instead of like.
Fantastic.
Yeah.
Yeah, I'm very happy. I was very happy to see that. And I also saw the log that you cleared.
Yeah, I was like, yeah. And I guess two more clarifying questions. So the important dates that we should worry about for like the the quest is just like Sunday, right? Like Sunday is like freezing date.
Yes, Sunday night.
That's when it's due. And then the
Monday
reflections
morning.
is
Monday
or Mo-
morning.
Monday morning.
8 a.m. Monday morning. If you can get it in like 6 a.m. or something, that's fine
Okay.
too.
Okay. And then for the reflections is Friday night on Reddit.
Sunday nights.
Or-
Both of those on Sunday
Oh,
night.
okay, 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 yeah. It's just because you were mentioned that like, oh, don't take more than like just one other STEM class, but unfortunately, I can't do that. I have to take physics, computer science, and math at the exact same time every
No,
quarter.
no, that's okay. Only 3, right?
There's-
Only those are the only 3.
Yeah, those are my only 3. Yeah,
That's
But-
fine. You
so
know, we've had students who took 5 STEM classes. Okay,
Jesus,
5,
yeah.
4, even 4 is bad. I
yeah,
think
no, yeah,
because each of those math, you need a lot of time for math.
yeah,
And physics too. So
Yeah.
because you
But-
need to work through all of the problems in the back.
exactly.
In the math
Yeah.
book. Yeah.
But one interesting thing is just like I'm also seeing this in this class where it's like they go kind of hand in hand. Or I guess because in physics it's calculus based, so of course it goes hand in hand. But here, like I notice how like someone must have just like some mathematician must have just seen like like if you divide everything by 2, you always get a remainder of 1 or 0, and so you can kind of like see a pattern there and like make it into
Yes,
code.
yes. And you know,
Yeah.
anytime you discover patterns like this, you don't have to look up saying which mathematician discovered this and so on.
Yeah,
You just
it just-
share it in the forum as though it
Mhm.
was you who discovered it.
Yeah.
Yes, then
Yeah.
that's that's how that person must have felt
Yeah.
too.
No, yeah, exactly. Yeah. Yeah, thank you
Say,
so
hey,
much.
I was looking at it and I found this pattern. Isn't that cool?
Yeah. But yeah, thank you so much for answering the questions and thank you for
No
today.
worries. All right, I'll
I'll
see you on Thursday.
Thursday. Yep, thank you.